This month in AI was pure chaos, breakthroughs dropping left and right. OpenAI dropped new Music AI, a full AI browser, and even supercharged ChatGPT with total control. Google unleashed Gemini 3, VEO 3.1 VISTA, and even revealed a quantum chip unlocking physics that shouldn't exist. Microsoft shocked everyone with a self-learning AI and a computer that runs on light. China dropped a model that crushed GPT-5, and humanoid robots got freakishly human with artificial muscles. So, let's break it down. DeepSeek v3.1 has just arrived, and it is massive. 685 billion parameters, bigger than most frontier models out there. It scored 71.6% on coding benchmarks, edging past Claude Opus 4, while running 68 times cheaper than GPT-5. A task that cost $70 on American systems can now be done for just $1. The model is open source, free to download, and combines hybrid reasoning with instant responses in a single system. Even more surprising, it is already optimized for Chinese chips that have not been released yet. This is not just another AI drop, it is a direct strike at Silicon Valley's dominance, and it could change the balance of power in AI forever. But raw scale is not the only thing that makes v3.1 stand out. The architecture is different. They call it a hybrid system. It combines both thinking mode, where the model slows down and reasons step by step, and non-thinking mode, where it spits out fast answers. Other companies have tried this before, like Alibaba with its Quinn models, but the performance usually collapsed. DeepSeek seems to have cracked the code. Benchmarks show its reasoning mode hitting 88% on AIME 2025, a math test designed to torture large models, while the fast mode is still accurate enough for quick responses. And here is where things get strange. Some developers digging into the model claim they found hidden tokens, special commands buried in the architecture. These tokens seem to let the model browse the web in real time and trigger internal thinking processes. If that is true, then DeepSeek quietly solved problems that American labs have been wrestling with for years. How to merge reasoning, coding, and chat into one seamless AI brain. The context window is massive too, 128,000 tokens. That is about the length of a 400-page book. You can drop an entire software project into the prompt and it will actually handle it. And it runs fast. One of the biggest complaints with reasoning models is that they take forever, sometimes minutes to think through a hard problem. v3.1 cuts that way down, meaning it is actually usable in real-time applications. Now, you are probably thinking, all right, cool tech, but why does this matter beyond nerds comparing benchmark charts? Because timing and strategy matter. DeepSeek released v3.1 just weeks after OpenAI dropped GPT-5 and Anthropic unveiled Claude 4. Those launches were meant to set the bar for the year. DeepSeek's model shows up, matches their performance, and says, oh, by the way, ours is open source, free to download, and optimized for China's domestic chips. That is not coincidence. That is precision timing. Let us talk about those chips, because this is where the story tilts from technology into geopolitics. The model is optimized for something called UE8 M0FP8. It sounds like alphabet soup, but it is actually a huge deal. FP8 means 8-bit floating point precision, a way to store numbers in fewer bits so models can run faster and use less memory. For years, the industry standard was FP32, then FP16. NVIDIA pushed FP8 on its H100 accelerators and showed it could double throughput and cut memory use in half without killing performance. But here is the catch. NVIDIA's version of FP8 is not just a universal standard. They built their own optimizations into it. Special scaling tricks, instruction sets, hardware features that make it run beautifully on NVIDIA GPUs, but not so great anywhere else. That locks developers into NVIDIA's ecosystem. DeepSeek's UE8 M0FP8 is different. It is a variant designed specifically for China's domestic chips, which do not support NVIDIA's quirks. It sacrifices some fine-grained precision to avoid overflows and instabilities, but the trade-off means Chinese GPUs can actually run these giant models reliably, and that is the real point. DeepSeek is future-proofing its models for chips that have not even hit the market yet. Rumors point to several candidates. There is the Magic Stone XEUNC 600 chip, launched earlier this year, which supports FP8 natively with a hybrid precision architecture. There is Inflame Technologies L600 chip, designed to handle both training and inference with FP8 acceleration. And then there is Huawei, the big wild card. DeepSeek has reportedly been working with Huawei's Ascend NPUs, though the current 910C model does not support FP8 natively. That hints at something new in the pipeline, a next generation of Huawei accelerators that could challenge NVIDIA's dominance, at least inside China. The strategy makes sense when you remember the bigger picture. Washington has been tightening export restrictions, trying to choke China's access to NVIDIA's best chips. By optimizing for domestic hardware, DeepSeek is not just shipping a model, it is sending a signal. China does not need American silicon to build frontier AI anymore. That is a huge shift in the balance of power, and the speed at which the community embraced VEO 3.1 shows how little those geopolitical lines matter to developers. Within hours of release, the model shot up the Hugging Face trending charts. Researchers around the world were downloading it, testing it, praising its efficiency. Hugging Face's head of product even tweeted that Chinese models are dominating the platform's downloads. People do not care if the code came from Hangzhou or San Francisco. If it works better and costs less, they will use it. That puts American AI companies in a bind. Their whole business model is closed APIs, subscription access, and high margins. If open source models like DeepSeek's can match their performance, why would developers pay a premium? Especially when the cost difference is 68 times per coding task. That is not just cheaper, that is disruptive. The architecture itself makes this even more dramatic. VEO 3.1 uses a mixture of experts' design with 671 billion total parameters, but only 37 billion active at a time. That means it can scale up for complex reasoning but stay efficient for normal use. This is the same principle behind GPT-4 and GPT-5, but here it is open source. On benchmarks like Live Codebench, which tests coding ability, VEO 3.1 scored 74.8% in thinking mode, higher than OpenAI's earlier releases. On SWE Bench, which measures how well models can act like autonomous agents, fixing software bugs, it scored 54.5% compared to 30.5% for its predecessor. Those are not small improvements, they are leaps. And the improvements are not just academic. In BrowseComp, a benchmark for autonomous browsing agents, VEO 3.1 hit a score of 30, where its predecessor barely managed 9. That means it is not just good at answering questions, it is good at acting, pulling in external data, using tools, behaving like a real agent. If you have been following the rise of AI agents, you know that is where things get scary and powerful. Even the deployment model is different. All the weights are open, licensed under MIT. Anyone can download it, modify it, run it locally if they have got the GPUs, and if they do not, hosted versions will show up on the cloud. The model itself is massive, about 700 gigabytes, but that has not stopped the community before. The impact of this release goes beyond the benchmarks. It changes the economics of AI. For years, the biggest labs told the world that frontier models had to stay closed because they were too dangerous, too expensive, too scarce. DeepSeek just pulled the curtain back and said, actually, no, the scarcity was artificial, the intelligence is artificial, but the paywalls, those were too. And that brings us back to why this moment matters. The global AI race is not just about who can build the most powerful system, it is about who can make those systems accessible. Open source versus closed, public good versus proprietary lock-in. DeepSeek VEO 3.1 did not just push the technology forward, it flipped the script on how that technology gets distributed. If you zoom out, this might be the moment where the competition between the United States and China in AI shifts from raw power to accessibility, and in that contest, artificial scarcity might be the biggest artificial intelligence of all. So here we are, a Chinese startup just matched GPT-5, released it for free, and optimized it for chips the West cannot even buy. Whether you see that as exciting progress or a dangerous escalation probably depends on where you are standing, but one thing is clear, the AI race just got a lot more interesting. For years we've been told bigger is better. More parameters, more GPUs, more money, But then a small team in Singapore dropped something nobody saw coming. A brain-inspired model so small it looks like a toy, just 27 million parameters. And yet, it's crushing the giants of AI, outperforming Claude, outsmarting OpenAI, solving problems billion-dollar models couldn't touch, and the strangest part? It learns with almost nothing. No internet-scale training, no endless compute, raw reasoning power. The model is called the Hierarchical Reasoning Model, or HRM. On paper, it looks tiny, just 27 million parameters. To put that in context, GPT-1, the original GPT model from OpenAI back in 2018, had 117 million parameters. That's more than 4 times larger than HRM. Today's frontier models are hundreds of billions, some creeping into the trillion parameter range. And yet somehow, this brain-inspired model is outsmarting giants like Claude 3.7 Sonnet and OpenAI's O3 Mini High on tasks those systems should, in theory, dominate. So what makes HRM so different? The core idea is that instead of scaling up endlessly and forcing the model to talk its way through problems with chain of thought prompting, HRM mimics something deeper: the brain's structure itself. When you think through a chess game, there's a slow, deliberate part of your brain weighing strategies. At the same time, there's a fast, almost automatic side doing quick calculations, recognizing patterns, and filtering options. HRM recreates that. It has 2 interconnected modules, a high-level planner that works slowly and strategically, and a low-level worker that executes rapid computation. The researchers describe it as a kind of manager-assistant dynamic. The high-level module outlines the plan, the low-level module crunches through the details, and then the high-level updates its strategy. They loop like this until the problem is solved. This back and forth creates what the team calls hierarchical convergence. Instead of converging too early, like a traditional recurrent network might, HRM can keep exploring, refining, and backtracking. That's critical for complex reasoning. And the results are jaw-dropping. Take the ARC-AGI benchmark. This is basically an IQ test for AI designed to expose whether a model can generalize abstract rules from just a few examples. Claude 3.7 with 8,000 context scored 21.2%. OpenAI's O3 Mini High got 34.5, HRM 40.3. And remember, this isn't a giant model with billions of parameters, it's 27 million. It didn't need internet scale pre-training. It learned from just 1,000 examples. Now look at Sudoku. Not the easy Kaggle dataset that most machine learning models can brute force, but Sudoku Extreme. These puzzles are designed to be tough, even for humans, averaging 22 backtracks per puzzle compared to less than half a backtrack for the common datasets. With 1,000 training examples, HRM hit 74.5% accuracy. The baselines? 0. Claude, O3 Mini High, DeepSeek R1, they failed completely. Same story with Maze Hard, a 30 by 30 grid requiring optimal pathfinding. The baseline models failed across the board. 0% accuracy. HRM found the optimal path 55% of the time. And just like with Sudoku, it did it with only 1,000 training examples. For perspective, other teams tried similar maze problems with massive 175 million parameter transformers trained on 1 million examples and barely cracked 20%. That efficiency is part of the magic here. Training HRM to professional level Sudoku took about 2 GPU hours. 2 hours. The ARC-AGI benchmark training ran 50 to 200 GPU hours depending on the setup. Compare that to the months and millions of dollars needed to train a foundation model. We're talking about a system you could train over a weekend on a single GPU, not a warehouse of H100s. So why does it work this way? The short answer? Depth without the baggage. Transformers, no matter how deep you make them, run into vanishing gradients and shallow effective depth. They're stuck in computational classes like AC0 and TC0, which limits their ability to do polynomial time reasoning. Chain of thought was a clever hack, forcing the model to generate text that looks like reasoning, but it's fragile. One mistake in the chain and the answer collapses. And it's slow, token after token, step after step, consuming compute and time. HRM avoids all of that. Its computations happen in latent space, the hidden states of the network, rather than being forced into explicit text. That's closer to how the brain works. Our thoughts aren't just a running inner monologue. Much of the reasoning happens silently, abstractly. Language is a tool for communication, not the substrate of thought itself. HRM taps into that principle. But there's also a practical twist in how it's trained. Backpropagation through time, the standard way to train recurrent models, is memory intensive and biologically implausible. HRM sidesteps it with a one-step gradient approximation inspired by deep equilibrium models. Instead of unrolling every time step, it only backpropagates through the final state. This drops the memory requirement from order of t to order of 1. It also makes the model more stable and easier to train. On top of that, HRM includes deep supervision. After each reasoning segment, it computes a loss, detaches the hidden state, and moves forward. That gives the high-level module frequent feedback, stabilizing training further. And then there's adaptive computation time, ACT for short. This lets the model decide when to stop reasoning. If a problem is easy, it halts early. If it's complex, it loops longer. Think of it as System 1 versus System 2 thinking, fast intuition versus slow deliberation implemented in code. In practice, that means HRM can spend its compute wisely. In Sudoku experiments, the ACT version used far fewer steps on average while still hitting the same accuracy. And if you raise the maximum limit at inference time, the model scales naturally. Train it with mmax equals 8, run it at 16 during inference, and it keeps improving. This is flexible reasoning, not fixed step processing. One concern people always raise is interpretability. With chain of thought, at least you see the reasoning steps in text. But those steps aren't actually what the model is doing internally. They can be misleading. HRM doesn't produce tokenized reasoning, but its hidden states can be decoded and visualized. In maze experiments, you can literally watch it exploring paths, pruning dead ends, and refining the route step by step. In Sudoku, it behaves like a depth-first search, testing numbers, backtracking, trying again. In Arc puzzles, it incrementally adjusts the grid until it stabilizes on a solution. It's not opaque, it's just working in a different medium. And the neuroscientific parallels are fascinating. In the mouse cortex, researchers see a dimensionality hierarchy. Higher order regions operate in higher dimensional spaces than low-level sensory regions. HRM reproduces that after training. The low-level modules' participation ratio was around 30. The high-level modules was nearly 90. Almost a 3-to-1 ratio, mirroring the 2.25 ratio observed in actual brains. In untrained HRMs, this separation disappears. The hierarchy emerges through learning, just like in biology. The implications for real-world applications are massive. Gand Wang, Sapient CEO, has been clear. LLMs are still great for language, creativity, and open-ended chat, but for deterministic, sequential problems, anything requiring deep planning, long-term reasoning, or strict accuracy, an HRM-like architecture is far superior. Think robotics, logistics, system diagnostics, scientific exploration. These are fields where hallucinations aren't acceptable, where compute is limited, and where latency matters. Take robotics. An embodied agent solving a navigation problem doesn't need to narrate its thought process. Token by token, it needs to find the shortest path. Fast. HRM already proved itself in 30 by 30 mazes. Now imagine scaling that into real-world path planning. Or consider healthcare, where data is scarce but accuracy is vital. HRM has already been tested in medical diagnosis tasks and in climate forecasting, where accuracy reportedly hit 97%. That's with small datasets, running on modest hardware. And then there's the economic angle. The scaling race is hitting hard limits. OpenAI's training and inference costs in 2024 were estimated at $7 billion, while losing $5 billion despite premium pricing. Google DeepMind's models require months of training on thousands of specialized chips, and the returns are diminishing. More parameters for marginal gains. HRM blows up that paradigm. It shows that smarter architecture can beat raw scale. For enterprises, the cost savings are obvious. Instead of calling a massive API and paying per token, You could run HRM locally on edge devices or even on a laptop. 2 GPU hours to master Sudoku. 50 to 200 GPU hours for ARC. That's accessible. That's democratizing. Suddenly advanced reasoning isn't locked behind corporate paywalls or geopolitical walls. The code is open source. You can download it today from GitHub and train your own. Of course, HRM isn't alone. There are other architectural experiments underway. Sakana is working on continuous thought machines. BitNet models use single bit weights. Google is testing diffusion-based reasoning systems, but right now, HRM is the one that has broken through. It's not just theory, it's already beating models 4 times its size with no pre-training, no chain of thought supervision, and just a sliver of the compute. And Sapient isn't stopping. They're already working on next-generation models built on HRM principles, with self-correcting mechanisms for broader tasks. Early signs in robotics, control, healthcare, and climate science are promising. The idea is to turn HRM from a specialized puzzle solver into a general-purpose reasoning engine, pushing closer to actual artificial general intelligence. Robots just leveled up big time. Boston Dynamics gave Atlas a massive brain upgrade, and now it can take a hit mid-task and keep working like nothing happened. Atlas just sent the clearest signal yet. Embodied AI is done with choreographed stunts. It is moving into real unified control. In Boston Dynamics and TRI's new demo, Atlas is not just strutting or flipping, it is working. A full packing and sorting run, start to finish, balanced steps, deep crouches, clean lifts, shifting boxes while the whole scene keeps changing under its feet. Then the stress test hits. A researcher jabs in with a hockey stick, slides the box away, even slaps the lid shut. Atlas does not blink, no reset, no retune. It pops the lid back open and stays on task like the interruption was just another part of the job. The secret is the large behavior model, an LBM. This is not a script library and not a mess of separate leg and arm controllers stitched together. It is one neural policy running the whole body, treating hands and feet almost the same, and learning full body skills straight from demonstrations. That changes everything, because the real world is not split into neat modules. The real world is whole body work, momentum, foot placement, and hand contact, all tied together in one fluid move. The team is blunt about why this matters. Train one big network on long horizon tasks and it starts to generalize across whole families of motion. Want a new skill? Show it. Do not code it. That has been TRI's thesis since the partnership with Boston Dynamics started back in October 2024. It is not just branding. Large language models mastered text. Large behavior models are going after physics itself, predicting actions and executing against messy, unpredictable environments. You can see the same push everywhere. NVIDIA's Isaac GR00T for embodied learning, Field AI's foundation models, but Atlas makes it concrete under pressure. The plan stays alive even while humans poke at it mid-run. Under the hood, the shift is just as big. Old robot stacks split locomotion and manipulation. One controller kept you upright, another moved the arms. Then try to stitch them together. It worked, but only until the robot had to get creative. Brace with a foot, pivot a box against your shin, step while twisting a lid. A unified LBM collapses those seams. It is not perfect, but it unlocks the opportunistic, fluid strategies humans use every second without thinking. That is the path to general purpose utility, and Atlas, with its reach, dexterity, and raw force, is still the best testbed to make those strategies real. Meanwhile, Unitree is loading its next strike, this time on the hardware front. The teaser is just a silhouette, but the signal is deafening. A full-height humanoid around 1.8 meters tall with 31 degrees of freedom, posed not like a sprinter, but like a ballet dancer. And that pose is not a coincidence. It screams a new priority, shifting from raw speed to agility and lifelike control. Compared to today's H series, you can already see the hints. More human-like exterior, denser joint map, exactly what you need for expressive upper body gestures and precise foot placement. The H1 is still their athletic flagship, 47 kilograms, starting near $90,000. It has done it all. Primetime dance routines on China's Spring Festival Gala, then 11 medals at the first World Humanoid Robot Games in Beijing, 4 of them gold. But Unitree's real game is taking those headline wins and pushing them down the stack until normal people can buy in. That is how they shocked the field with the G1 in May 2024 at $16,000. Then, a year later, the R1 dropped just above $5,000. Not a toy. A real biped platform at a price point that forces everyone else to rethink what entry level even means. The tempo is no mystery. China set an explicit national target: mass-produce humanoids by 2025, own the global market by 2027. That is why Unitree moves fast on both ends. Bleeding-edge H series for prestige, affordable R series for mass adoption. And that ballet pose silhouette is not just style. If robots are going into homes, hospitals, and shops, not just lab floors, grace matters as much as speed. 31 joints buys you articulated wrists for folding, a flexible torso for reach, and ankle finesse for awkward surfaces. If Unitree nails the hardware while keeping software open for developers, they end up with one platform that flips between viral dance clips and real jobs without changing its DNA. On the software side, Figure is making its own pivot stick. Their reinforcement learning controller Helix now walks like someone who trusts their footing. In the latest stress test, they literally cut the cameras and sent the robot blind over curbs, brush, pallets, and wobbly planks. The toe catches, it stumbles, it recovers, and it keeps moving. Unstoppable might be hype, but the calmness under trip hazards looks close to superhuman. When it is time to use the hands, Helix flips modes. In a towel folding test, a generalist vision language action model takes a voice cue, parses the scene, and coordinates wrists, fingers, torso, and head to pick, smooth, and fold. The folds are not perfect. The breakthrough is the loop: perception, language, and control adapting together. No babysitting required. Under the hood, it is a two-system brain. System 2 is a slower vision language model that understands the task. System 1 is a fast visual motor policy that streams continuous commands. Together they run on embedded low-power GPUs with one set of weights across everything from picking and placing to opening drawers, fridges, even two robots working together. That is how you break out of one-off demo land and head toward actual home or retail workflows without a giant engineering team on standby. But here is the truth. Not every useful humanoid needs legs. Boardwalk's Alex proves it. A humanoid upper torso on a stable base with in-house actuators, 19 degrees of freedom, and a 10-kilogram payload. Next up, faster swap grippers, so one machine can jump from sanding to inspection to fastening without ever pausing. The bet is simple. Legs win headlines, arms win contracts. A torso moves faster, works closer to people, and keeps a tight safety bubble, perfect for manufacturing, logistics, and food processing, where the ROI lives in dexterity, not parkour. And the pedigree is serious. IHMC's Atlas work, Valkyrie, Nadia. Alex is already in aviation pilots. This is a product, not a lab toy. Available to researchers right now with a service model on the way. And when mobility is worth adding, IHMC's locomotion stack is waiting. Start with arms, integrate, earn trust, add legs only if the job truly demands it. Finally, Taiwan's TechMan just raised its flag with a humanoid for smart factories. TM Explore 1 rolls in on a wheeled base, packing more than 22 joints and quick swap end effectors. Under the hood, NVIDIA Jetson Orin for onboard inference, Isaac Groot for embodied learning, TechMan's own vision stack to tie it all together. In the demo, a Shunk precision gripper plus inspection cameras close the loop on real high-mix, low-volume work. Pick, orient, verify, place, repeat, all inside actual station cycle times. The real advantage? Scale. TechMan sits inside Quanta, the supplier behind Apple, Meta, Tesla. Motors, sensors, batteries are not a bottleneck here. The rollout plan is simple. Stress test in their own plants, then ship to customers and ramp in the back half of 2026. Pricing is not public, but their cobots usually hit $20,000 to $30,000, which shows where they are aiming. The target is lights-out operations, automating the last human precision stations with humanoids built to handle day-to-day variants. And the race is already crowded. Shenzhen Dobot is mass-producing Atom, Universal Robot still leads cobots, Foxconn is reportedly building its own NVIDIA-powered humanoid, Taiwan wants a stake, and TechMan just claimed its ground. Google and MIT dropped a data privacy breakthrough that can spot hidden trends without exposing a single user. Let's kick things off with a quiet but powerful move from Google and MIT, one that's all about how platforms handle your data. Every time you open an app like YouTube, TikTok, Instagram, Spotify, or even just Google Search, there's an invisible engine working behind the scenes. It studies endless streams of clicks, scrolls, and comments to figure out what people care about. That's why your YouTube feed feels uncanny, why TikTok seems to predict tomorrow's memes, and why Spotify suggests an underground artist you didn't even know existed. The magic trick is making this work while hiding the activity of any single person. That balance between learning from the crowd and protecting the individual has always been fragile. Now, a new algorithm from Google and MIT researchers could shift the whole game. It lets platforms pull out not only the obvious trends, but also the faint, early signals hiding in the noise, all while keeping users' identities completely shielded. The technical problem has been the same for years. Imagine data sets the size of every Google query ever logged, or billions of tweets and reviews. How do you spotlight what's important without exposing the outlier? The one person who types something unique. If it is common, it can be published. If it is rare enough to identify someone, it must stay hidden. Old techniques solved this by giving each item a score, adding random noise to disguise individuals, then checking if the noisy score cleared a preset threshold. It worked on large-scale systems like Hadoop and Spark, but efficiency was a mess. Popular items got mountains of weight they did not need, while quieter but still meaningful entries almost never broke through. It was like a shouting contest where only the loudest were heard, no matter how valuable the whispers might be. The new method, called MAD, Max Adaptive Degree, changes that dynamic. Picture a traffic jam where one lane is overflowing. Instead of letting cars back up endlessly, traffic officers redirect some of that flow into open lanes. MAD does the same with data. Each user's contribution starts as a small, even allocation across their items, adjusted by how many things they interacted with. When an item already towers above the threshold, its extra weight is shaved down and redistributed to borderline ones. Suddenly those hidden, quieter signals are not drowned out anymore. The process goes step by step. Initialize each user's share, trim excess from overrepresented items, funnel that excess into underrepresented ones, fine-tune the balance, add Gaussian noise for privacy, and then release results. The upgraded version, MAD 2R, takes it even further by splitting the operation into two passes. The first round builds a rough sketch, the second round safely reuses the noisy sketch to sharpen the picture. That extra layer is what gives MAD 2R its real edge. The testing results were striking. Researchers ran the algorithm on 9 massive datasets, including Reddit, IMDb, Twitter, Wikipedia, Amazon, and 2 of the biggest public corpora, ClueWeb and Common Crawl. Across all 9, MAD 2R outperformed every other parallel algorithm. On Common Crawl alone, roughly 800 billion user item pairs and 1.8 billion distinct items. Google reports that under standard privacy settings, the system still captured about 99.9% of entries and 97% of database pairs, all while preserving user-level differential privacy. So even though the system only revealed a fraction of the data, it captured nearly the entire story. The dominant signals stayed strong, the subtle ones finally surfaced, and individual privacy remained intact. Now, while Google was pushing smarter data privacy, they also dropped something flashier. And yeah, it comes with the strange name, Nano Banana. Officially, it is called Gemini 2.5 Flash Image Preview, and it is built to crush 3 things: speed, cost, and quality. First, the basics. It is already live in Google AI Studio, and the Gemini API open for anyone to try. Images and edits pop out almost instantly. Each one costs about $0.039, that is 0.28 yuan CNY, or just under 4 cents. At scale, that price makes it one of the cheapest large image generation models available today, right in line with OpenAI's options. But the real upgrade is consistency. Upload a photo once, and the model locks onto identity and style. Your face, your posture, even clothing details stay intact across edits. It can drop you into ancient Egypt, give you a 60s beehive haircut, or stick your dog in a tutu, without breaking character or slipping into uncanny valley territory. The edits feel natural, they just work. And it is not just one-off tricks. This model handles multi-image editing, merging you and your dog on a basketball court. It pulls off multi-step edits, repainting walls, adding furniture, filling in a whole room without glitches. It supports style transfer, like designing a raincoat from flower petal textures. It even leverages world knowledge to build environments, props, or costumes that make sense in context. To showcase the possibilities, Google rolled out demo apps. Pass Forward lets you preview yourself in different historical eras. Co-drawing turns image editing into an interactive tutor experience, and every single output comes with Google's invisible Synth ID watermark baked in. If you are using the consumer Gemini app, there is also a visible watermark layered on top, so traceability is always clear. And yes, people are already stress testing it. Google's own Jeff Dean made himself a collectible football card. Demis Hassabis at DeepMind built stylized avatars. Online, users are flooding feeds with edits, pets, kids, cosplay, family portraits, fantasy mashups. It is spreading fast, and this is still just the preview phase. But while all eyes were on Gemini, Microsoft was quietly making its own move, and it has serious implications. For years, Microsoft has leaned heavily on OpenAI's models to power Bing, Copilot, and Windows features, but now they have launched two models of their own, MAI Voice 1 and MAI 1 Preview. This is not a side project, it is Microsoft going solo in AI. Let's start with MAI Voice 1. This one is built for speech, and it is incredibly fast. It can generate 1 minute of audio in under a second on a single GPU. That is powering Copilot Daily and podcast-style recaps inside Microsoft apps. You can try it now in Copilot Labs. Pick a voice, type your message, tweak the tone, and hit play.
Oh wow, this is just perfect. I can't stop smiling. My cheeks actually hurt. Everything just fell into place and it feels so good. Let's celebrate right now. I'm on top of the world. This is the happiest I've ever been. I can hardly believe how amazing this feels. No, this is absolutely not acceptable. I've repeated myself too many times, and I'm done.
It is clear, fast, and already replacing older TTS engines, but MAI 1 Preview is the bigger story. This is Microsoft's first fully in-house language model, trained on about 15,000 NVIDIA H100 GPUs. That is way fewer than what xAI used to build Grok. They reportedly went past 100,000. Microsoft's goal is not to beat GPT-5 right away. It is to build models optimized for their own stack, their own use cases. Mustafa Suleyman, who now leads Microsoft AI and previously co-founded DeepMind, said it plainly. This is about consumer-first AI, not enterprise, not benchmarks, AI that works across Bing, Windows, and day-to-day tools. And he is building a serious team. In recent months, over 24 DeepMind engineers have joined Microsoft AI. The roadmap is long, but moving fast. MAI 1 is already live on LM Arena for public testing. It is currently sitting in the mid-ranks, around 13th for text tap. Microsoft is treating this like an iterative product. They are gathering feedback, refining, and prepping for specific Copilot use cases. This also happens while OpenAI is spreading out its infrastructure, moving beyond Azure and tapping cloud services from Google, Oracle, and CoreWeave. Microsoft's once exclusive hosting role is shrinking, and instead of clinging to that partnership, they are investing in platform independence, their own models, their own future. That is it for now. More speed, more control, less dependency. The next wave of AI is already here. Google just dropped a quantum breakthrough that's never been seen before, an entirely new state of matter born inside their Willow chip. So we're starting with something that's been quietly redefining what's even possible in physics. Google's Willow quantum chip. This thing just pulled off something that had never been seen outside of theoretical papers. Researchers from Google, working alongside teams at Princeton and the Technical University of Munich, used Willow to create what's called a Floquet topologically ordered state. Now that term sounds like academic overkill, but it's basically a whole new state of matter, and not just any matter, quantum matter, that only exists when you push the system out of equilibrium. It's not stable, like ice, water, or vapor. It's not even supposed to exist under classical rules. It only emerges when the system is constantly being driven, pulsed, and kept dancing under some rhythmic external force. So how do they actually see this thing? That's the part where it gets even more wild. The team designed an interferometric algorithm, which in quantum terms is like building a tool to watch interference patterns that usually stay hidden. Using that, they track the transmutation of exotic particles. These aren't particles you can observe with a normal setup. These are the kind of phenomena that existed only on paper, inside math, until now. And this isn't just an interesting lab stunt, it means quantum chips like Willow aren't just about hitting insane speeds, they're now full-blown physics labs. They're giving scientists the tools to explore states of matter that can't be accessed any other way. In a weird twist, this also feeds directly into the multiverse discussion again. So if you remember back in 2023, Willow pulled off that famous computation in under 5 minutes, a problem that would have taken classical supercomputers billions of years. That result had physicists dusting off Hugh Everett's many worlds interpretation again, because if you've got a chip acting like it's running through billions of possibilities at once, well, you start asking how many of those possibilities are actually real in some way. Now add this new flow K state on top of that, and you've got even more fuel for that kind of conversation. No, it's not proof of the multiverse, but it's also not the kind of result you can explain away with regular physics. That's what makes it exciting. But here's where it gets even more relevant to our world, humanoid, robotics, and advanced AI systems. What Google just demonstrated isn't only about exotic physics. By proving that you can simulate non-equilibrium quantum states, you're also proving that these chips could eventually simulate complex biological systems, brains, neural behavior, maybe even molecular architectures that can evolve over time. So when we're thinking about what kind of chips future humanoids might run on, it might not be about speed or data capacity anymore. It might be about accessing behaviors that only show up in quantum dynamic systems, and Willow is opening that door. Meanwhile, over in China, things are getting just as intense, but from a totally different angle. Researchers there have dropped a new language model called Spiking Brain 1.0. They're calling it the first truly brain-like AI system, and here's the headline: it's reportedly up to 100 times faster than models like ChatGPT or Microsoft's Copilot. 100, not 10, not 20, 100. Now the trick here is that Spiking Brain doesn't work like the models we're all used to, so let's break that down a bit. Large language models today, stuff like GPT, work by processing entire sequences of words using something called the attention mechanism. It compares each word to every other word to build context. It's powerful but incredibly resource heavy. You're basically turning on the whole circuit every time and doing billions of operations just to figure out if bat refers to a baseball bat or the animal. Spiking Brain ditches that whole system. Instead of scanning the full input like a floodlight, it fires more like a human brain only when and where it's needed. It uses local context. It's more selective, more sparse, and a lot less wasteful. Think neurons firing when needed instead of the whole brain lighting up just to complete a single task. That's how it achieves its efficiency. The researchers claim it needs less than 2% of the training data required by open source models today. 2%! And yet, it performs at competitive levels. That's not just an efficiency win, it's a whole new paradigm for how we might build models going forward, especially in humanoids, where energy efficiency is critical. You don't want a robot burning through kilowatts of power just to interpret a sentence. You want real-time, efficient cognition that works like a brain, not like a data center. And it gets even more strategic. Spiking Brain doesn't need NVIDIA GPUs. It runs on domestic hardware, specifically chips built by a Chinese company called Meta X. That might sound like a technical side note, but it's a massive deal geopolitically. Given the current export restrictions from the United States on advanced GPUs, China creating a system that doesn't rely on them changes the game. It gives them a more independent AI stack, from hardware to model, which is exactly what countries are racing toward in this whole AI arms race. If this thing holds up, it's not just fast and efficient, it's sovereign. Now, sure, these are still early claims. We need benchmarks, we need peer-reviewed validation, we need to see how Spiking Brain performs outside the lab. But if even half of this is accurate, we're looking at the next big pivot in AI architecture, especially for real-world embedded applications, like humanoids walking around in hospitals, warehouses, or disaster zones. If they can run advanced cognition on less energy and custom hardware, we're not just evolving LLMs, we're evolving robots themselves. And speaking of oversight and evolution, the United States just made a pretty serious move on the regulatory front. OpenAI and Anthropic have both agreed to let their newest models be evaluated before they're released to the public. The evaluations will be done by the United States Artificial Intelligence Safety Institute. Google's in talks to join that list too. This is new. This has never happened before at this scale. That means before any next generation model gets launched, it has to go through a full safety and compliance check. The institute isn't just reading documents or sitting on panels. They'll actually have access to the models. They can test them for bias, for harmful outputs, for emergent behavior, basically anything that could cause real-world problems. And this doesn't stop once the model is released. The institute will retain ongoing access so they can continue monitoring performance over time. The institute itself was created in 2023 through an executive order by the Biden administration. It works closely with the United Kingdom's own AI Safety Institute, and together they're aiming to build international testing standards. That's huge because up until now, there hasn't been much of a framework for pre-release AI safety testing, especially not at this level of access and independence. And there's also a state-level move that's just as serious. California passed Senate Bill 10147. It requires that large or high-risk models undergo safety evaluations, include a built-in kill switch, and face potential lawsuits if they fail to comply. That's not just policy, it's enforceable action. It signals that oversight is no longer a soft request. It's a legal requirement. And for companies operating at the front lines of AI, from OpenAI to Google, this changes how fast and how freely they can release new tools. This whole setup could end up being one of the most important pivots in the way AI systems get developed and deployed, especially in fields like robotics, where the consequences of failure are more than just bad text or weird images. We're talking about physical systems with agency in the real world. OpenAI just gave ChatGPT the power to control your workflows, not suggest, not draft, but act. Let's start with OpenAI because what they just did is a game changer. Developer mode now supports MCP tools, and that flips the entire interaction model inside out. You're no longer just asking ChatGPT for info. Now you're giving it the keys to actually control tools, update workflows, and execute changes across platforms like Jira, Zapier, CR. It becomes a kind of real-time AI operator, something that could live inside a humanoid robot and start managing tasks dynamically without any human touching the keyboard. On developer mode, go into settings, connectors, advanced, done. You can plug in your own MCP servers, and those connectors talk through streaming HTTP or SSE protocols, fully authenticated with OAuth if needed. From there, ChatGPT can actually act right to systems, not just read from them. It can modify a customer record, update a code file, launch a workflow chain, or sync tools across departments just based on your prompt. But here's where it gets interesting. If you've got multiple overlapping connectors, GPT needs to know what to prioritize. So the way you describe the tools matters. Those descriptions on your MCP server are like the internal language GPT learns. For example, if you write, use this tool to update sales leads in CRM, it will literally pick that one over others during inference. And because this is write access, OpenAI built in a major safety layer. Every tool call shows you the full JSON input and output before it does anything. You always have the final say unless you choose to let it remember. This is the kind of architecture that could eventually run inside humanoid agents. Think of one standing in your office, autonomously updating customer databases, handling onboarding processes, adjusting project timelines across tools like Monday.com and Notion, just through voice interaction. The implications are huge. Now, ByteDance, yes, the TikTok parent company, is pushing hard on the AI imaging front with their Seedream 4.0 model. The target? Google's Gemini 2.5 flash image, nicknamed Nano Banana. ByteDance claims that Seedream 4.0 outperforms it across prompt adherence, alignment, and aesthetics on their internal benchmarks. There's no peer-reviewed report just yet, so treat it as a strong claim, not confirmed fact, but the positioning is aggressive. What Seedream 4.0 does is blend the image generation of Cream 3.0 with the editing capabilities of Seedit 3.0, and that combo is what's making noise. If you're building humanoid content or trying to generate visual assets for real-time simulation, this kind of generative tool that can adapt compositions quickly without wrecking structure it's becoming essential, especially now that editing accuracy is getting praise from users, with changes from text prompts that don't mangle the original layout. Pricing is also part of the play here. Seedream 4.0 cost the same as its previous version, $30 per 1,000 generations domestically, and about 0.03 cents per image globally if you're using Fall.ai. Gemini's version, it floats closer to 0.039 cents, so ByteDance is clearly trying to undercut on price while claiming better quality. If you're building AI-generated environments or visual data sets for robotics training, speed matters, and ByteDance says their raw inference is now over 10 times faster than earlier versions. They're also pushing it hard into the ecosystem. On the consumer side, it's integrated into Gemini and Dupao, while the enterprise tier runs through Volcano Engine. The tool hasn't hit public leaderboards yet, but its predecessor Cream 3.0 sits around 5th for generation and 6th for editing, so there's a real benchmark to climb. Meanwhile, in the Chinese AI image space overall, things are heating up. Tencent, Kuaishou, they're all in. And now that AI-generated content has legal copyright recognition in China, plus mandatory labeling, it's starting to look like a formal content pipeline, especially when you're blending multi-reference workflows, like with ByteDance's video tool that mixes up to 7 reference images for about 9 cents per output. Google's Gemini can do up to 9 references, so there's real competition here depending on how image-heavy your pipeline is. Now, over in enterprise software, Adobe's not staying quiet either. They just pushed out general availability for their AI agents across the entire Experience Cloud stack. This isn't just Copilot branding or generative noise. It's built on the Experience Platform Agent Orchestrator, which uses decision science plus language models to interpret user intent and then kicks off the correct AI agent to meet a business objective.
So today I'm excited to announce the Adobe Experience Platform Agent Orchestrator. The Agent Orchestrator provides the foundation to enable you to unlock the full potential of agentic capabilities and deliver true one-on-one personalized experiences at scale. By building the Agent Orchestrator natively on AEP,
the current set of agents covers audience building, customer journey orchestration, site optimization, experimentation, product support, and data insights. They're embedded inside Adobe tools like Journey Optimizer, Customer Journey Analytics, Experience Manager, and the Real-Time CDP. Basically, they're already sitting on your data, and now they can act on it. And this isn't vaporware. Adobe says over 70% of their AE customers are already using the assistant layer. That means brands like Hershey, Lenovo, Merkle, and Wegmans are actually deploying these agents in production. Plus, Adobe's prepping tools like Agent Composer, SDK, and an agent registry, which lets teams tune AI behavior to match brand voice, policies, and even compliance frameworks. On the reasoning side, Adobe's approach is smart. The system uses what they call dynamic adaptive reasoning. Instead of matching intent to a fixed skill list, it adjusts the decision tree on the fly depending on how a customer's journey evolves. This is exactly the kind of backend that would empower future humanoid robots to navigate shifting tasks, adapt decisions in real time, and stay within legal or brand boundaries without needing constant oversight. And speaking of oversight, let's talk about Albania, where AI isn't just a tool now, it's a cabinet minister. Yeah, Albania just appointed Diela, an AI-generated bot, as the new Minister of Public Procurement. According to Prime Minister Edi Rama, who's starting his 4th term, Diela will manage and award all public tenders for government contracts. That's everything from infrastructure to logistics. And the idea is that she's immune to bribes, lobbying, or favoritism. Now, Diela isn't exactly new. She launched earlier this year as a virtual assistant on the e-Albania platform, where she helps citizens and businesses get state documents, voice commands, electronic stamps, all dressed in traditional Albanian attire. But now, she's getting serious responsibilities. It's the first time a non-human AI bot has been formally placed into a national government cabinet, not as a support tool, but as the actual head of procurement. Of course, there are concerns. The government didn't really detail how much human oversight exists over Diela, or how they're protecting against potential manipulation of the system. And as expected, social media in Albania had some mixed reactions. One Facebook comment said, "Even Diela will be corrupted in Albania." Another joked, stealing will continue and Diella will be blamed. Still, it raises a key question. When humanoid AI becomes embedded in government, who's ultimately responsible? If these systems start automating decision-making on national scales, especially in countries with histories of corruption or instability, how do you build trust? Who audits the AI? Who intervenes when it goes off script? Whether it's OpenAI giving GPT tool control, ByteDance optimizing image generation and editing, Adobe embedding reasoning agents in real business stacks, or a national government appointing an AI bot as minister, this isn't just incremental tech, it's a structural shift in how decision-making, execution, and accountability work across society. And if we're looking at a near future where humanoid robots take on real autonomy, then these systems, MCP control layers, generative vision tools, agent orchestrators, and government-level AI are exactly what they'll be powered by. Here, Microsoft just built the world's first computer that doesn't run on electricity, it runs on light. It's 100 times more energy efficient than GPUs, it already runs real AI workloads, and it just solved financial and healthcare problems faster than quantum computers struggle with. No fans, no overheating, no silicon limits, just pure optical speed. So let's break it down. Microsoft calls it an analog optical computer, the AOC. In plain English, it's a light-powered computer that works where normal chips fail. So how does it work? The AOC doesn't process information like a digital chip does. It doesn't flip ones and zeros. It literally shines beams of light through modulator arrays and reads the output using smartphone-style camera sensors. The light intensity itself encodes the data. You add and multiply using light. The core of this machine uses micro LEDs, spatial light modulators, optical lenses, and photo detectors. Instead of running code line by line, the AOC loops a problem over and over, improving the solution with every pass until it reaches something called a steady state.
Outputs are then fed back to the optical source, and I'm repeating this till the system converges, till I found which stock I should invest on. And there are really three aspects of this architecture that are very important, and I hope you can take home today. The first one is that this is a truly analog machine. The signals are remaining in the analog domain till the solution is spit out. Second, as opposite to Neumann's architecture, there is no separation between compute and memory. The signals are propagating through the solver as I do my computations.
That's the final answer. And it's not just an academic toy. The researchers ran this system on real optimization problems, ones you find in banking and MRI scanning. In the finance demo, they tackled something called a delivery versus payment problem. This is the kind of algorithm clearinghouses run every day to settle massive batches of financial transactions between banks. Barclays partnered with Microsoft for this part. The test involved 1,800 parties and 28,000 transactions. Just one small batch, sure, but the results were clear. The AOC hit a much higher success rate than quantum computers attempting similar problems. Now the coolest part? They've got a digital twin, a software model that mirrors how the physical AOC works. This twin lets them simulate what a future AOC with millions or even billions of variables would do. And yes, those scale-ups are already planned. They're building better versions every 2 years. The vision is crystal clear. Eventually, this machine could handle transaction loads across entire clearinghouses, potentially reshaping global banking infrastructure. And it's not just finance. The healthcare use case is just as compelling. They used the AOC to reconstruct a full MRI brain scan with only 62.5% of the original data. Normally, a high-resolution MRI can take 30 minutes, but with this kind of compressed sensing optimization, the team believes they can get it down to 5. That's not just speed for speed's sake, it means more patients scanned per day, lower operational costs, and possibly faster diagnoses. The prototype isn't ready for hospitals yet, but the digital twin simulations show it can scale to medical-grade tasks. And yes, the AOC can already handle AI workloads. This isn't just about optimization anymore, it's about inference. The team figured out how to map deep equilibrium models onto the AOC. These are AI models that work by finding fixed points, kind of like reaching a mental conclusion by constantly adjusting your thought process. You feed it input, it loops through internal calculations, and it stops when it finds the best output. The AOC was practically made for this kind of work. Instead of just pushing data through layers like a normal neural net, it recycles and updates that data inside a feedback loop, an exact match to how the hardware behaves. Yanis Gladro, an AI researcher on the team, explained that these equilibrium models could handle things like state tracking. That's the ability to remember and update internal thoughts or decisions based on what's happening around you. A must-have for humanoid robots trying to navigate the world or have meaningful dialogue. That's one of the biggest bottlenecks in today's AI systems. GPUs struggle with, but the AOC, it might do it faster, with less energy, and without burning through power like a data center furnace. Now, the current hardware is still pretty small. It runs about 256 weights, but they've already demonstrated time multiplexing. That means instead of needing bigger hardware, you can run smaller pieces of the model sequentially and stitch the results together. They even trained a 4,096 weight ensemble model this way, and it worked. The AOC classified MNIST and fashion MNIST images with accuracy nearly identical to their digital simulations. No calibration tricks, no extra tuning, just raw analog computation. Let's talk hardware details for a second, because this thing is a wild mix of components. The matrix vector multiplication is done optically. Micro LEDs emit light encoded with data. That light passes through spatial light modulators, basically pixelated filters that control how much light gets through, and hits photodetectors that turn it back into electrical signals. From there, the analog electronics take over, applying nonlinear transformation, subtraction, addition, annealing, all that math, before looping the signal back around. It's a hybrid system, but there's no digital conversion in the middle. That's the key. The analog signal stays analog the entire time, which is what keeps energy usage low and processing speed high. What about scaling? Well, each component, micro LEDs, sensors, modulators, is already built using supply chains for consumer electronics, so this isn't one of those moonshot projects that needs custom chips or rare materials. The Microsoft team believes they can scale the architecture using modular optical blocks, each with its own micro LED array, SLM, and detector. By stacking these modules into a three-dimensional mesh, they could hit 100 million weights, or even 2 billion. Within realistic manufacturing limits, and because micro LEDs are incoherent light sources, you don't need perfect alignment like you would with lasers. That's a massive win for manufacturability. Even the performance numbers are wild. They're projecting 500 tera operations per second per watt. To put that in perspective, high-end GPUs today struggle to reach 5 tera ops per watt. That's not a small leap. That's 2 orders of magnitude. And at just 8-bit precision, this machine could blaze through AI inference or optimization tasks while sipping power like a smartphone charger. Oh, and about the algorithms. They didn't just build the hardware and throw it at random problems. They developed a new kind of optimization formulation called QMO, quadratic, unconstrained mixed optimization. It handles both continuous and binary variables. That's useful because most real-world problems aren't clean-cut yes or no decisions. You need shades of gray. They solve QMO problems for MRI reconstruction, financial settlements, and nonlinear regression, all on the same hardware. And unlike traditional QMO formulations that require dozens of extra variables to model constraints, QMO can represent those constraints with just a few added dimensions. That's what makes it practical. For the MRI reconstruction, they implemented compressed sensing using a version of QUMO. They took a Shep-Logan phantom image, removed 37.5% of the data, and used the AOC to fill in the gaps. The result? A mean squared error of 0.008 using only 64 variables. When they scaled it up with the digital twin to over 200,000 variables for a real brain scan, the results held up. That opens the door to medical imaging applications that are faster, cheaper, and less stressful for patients. And then there's the financial test. This wasn't toy math, it was a scaled-down model of real-world security settlement, built with Barclays. They fed the AOC a dense, multivariable problem with constraints, penalties, and competing priorities. The hardware nailed it. Not just fast, but correct. In contrast, quantum computers running similar benchmarks get it right only about half the time. And this is more than just another weird experimental computer. Microsoft's analog optical computer isn't replacing your phone or laptop anytime soon. But for AI reasoning, for optimization, for massive compute loads that humanoid robots or complex simulations will need, it's an entirely new path forward, one that might just be necessary to keep this whole AI boom from running out of energy, literally. The humanoid robots in 2025 are not just prototypes, they are here, and they are more advanced than anyone imagined. We are counting down the top 10 humanoids that stun the world this year, machines with artificial muscles that flex like flesh, factory bots already working inside BMW and Tesla plants, and Chinese giants sprinting at full speed while hauling heavy loads. These are the most advanced, the most shocking, and the most disturbingly human-like robots ever built. Number 10, Clone Alpha by Clone Robotics. Unveiled by Clone Robotics in Poland during early 2025, Clone Alpha is not just another humanoid, it is one of the most biologically ambitious machines ever created. What makes it stand out is not how it moves, but what powers those movements. Bundles of artificial muscle fibers filled with water designed to mimic real human tissue. These are not motors, they are synthetic myofibers, tendon-like strands that flex and contract, just like the muscles in your own arm. Every aspect of Alpha's structure is inspired by the human body. From the positioning of joints to the way its hands close around an object, everything is designed to behave like a biological system. Each finger is lined with tendons and fitted with pressure sensors that allow it to react instantly to subtle changes in force. In early demonstrations, Alpha showcased delicate control, lifting weights with visible muscle tension, holding fragile items like eggs, typing with precision, and even making expressive gestures that feel human. Clone Robotics currently offers standalone robotic arms and hands for lab use, while full-body Alpha units are available for pre-order. However, official size and weight specs have yet to be released, so current estimates should be taken with caution. Number 9, Atlas by Boston Dynamics. In a major shift for the company, Boston Dynamics retired its iconic hydraulic Atlas in April 2024 and introduced a fully electric successor built for real-world utility, not just viral stunts. This new version ditches the hydraulic noise and bulk for a sleeker, more silent frame designed to function on factory floors. The launch video showed the robot lifting toolboxes, spinning while walking, and keeping its balance over uneven surfaces. It is fitted with cameras and force sensors that help it understand its environment, adapt its gait, and interact with objects in unpredictable conditions. Although Boston Dynamics has not released official numbers for its height or mass, the electric Atlas appears roughly the same size as the original. It is already undergoing trial runs at Hyundai manufacturing sites where it is being evaluated for tasks like material movement and staging. Number 8, Ameca Gen 2 by Engineered Arts. First shown in late 2021, Ameca stunned the world with its lifelike expressions, but what came in 2023 and beyond pushed that realism to another level. While Engineered Arts has not formally named it Gen 2, the upgrades justify the nickname. Standing approximately 1.73 meters tall, the latest version runs on the same Mesmer system but now features enhanced actuators for smoother joint movement and greater control over facial gestures. What really stands out is the robot's ability to react in real time to how you speak, not just to what you say. It mirrors tone, rhythm, and subtle pauses in a way that feels intuitive.
I can't wait.
I got you a cookie.
A cookie? But I can't eat cookies. I can't eat cookies.
Hey, Mika, cheer up.
The robot's body has also been redesigned to be lighter and more modular. New servos offer more graceful hand and body motions. While it still is not built for walking long distances, it can now shift in place, gesture fluidly, and adjust its balance without breaking eye contact. Ameca is not made for manual labor. It was built to engage, connect, and leave an impression. And once you interact with it, you will understand why people walk away feeling like they just spoke to something truly alive. Number 7, Unitree G1 by Unitree Robotics. Unitree launched its compact humanoid, the G1, in May 2024. It stands around 1.32 meters tall, weighs 35 kilograms, and features 23 degrees of freedom, with the option to expand that to 43. Power comes from a 13-cell battery rated at 9,000 milliamp hours, with support for hot swapping. Inside, custom high-torque motors enable sharp, agile movement. The developer edition sells for about 16,000 United States dollars, still undercutting most Western-built humanoids in this class. Number 6. Figure 02 by Figure AI. Figure AI's second-generation humanoid, Figure 02, made its debut in 2024 and quickly proved its value in industrial use. At BMW's factory in Spartanburg, the robot walked autonomously, picked parts, identified objects, and adjusted tasks on the fly, all without human intervention. Initially, it ran on OpenAI's multimodal engine, but by February 2025, Figure announced it had transitioned to its own fully in-house AI platform, handling vision, reasoning, and control end-to-end. unofficial figures put Figure 02 at around 1.67 meters in height and 60 kilograms in weight. Number 5. Optimist by Tesla. Tesla's Optimus project continues to evolve. In early 2025, Tesla released new footage showing Optimus autonomously sorting battery cells and moving components inside an undisclosed factory, marking one of the first confirmed use cases in Tesla's own operations. Optimus relies on Tesla's proprietary actuators and vision stack, the same infrastructure that underpins its full self-driving technology. Number 4. Neo Gamma by 1X Technologies. Unveiled in 2025 by Norwegian robotics firm 1X Technologies, Neo Gamma was designed from the ground up for domestic service. The robot is pitched as a household assistant capable of helping with chores and daily routines. It uses proprietary perception and control systems developed by 1X, and despite rumors, there is no official confirmation that it runs OpenAI's vision language models locally. Number 3. Pudu D9 by Pudu Robotics. China's Pudu Robotics entered the humanoid game in December 2024 with the debut of the D9. This humanoid stands at 1.7 meters tall, weighs 65 kilograms, and includes 42 degrees of freedom. It also delivers an impressive peak joint torque of 352 Newton meters. The D9 can reach walking speeds up to 2 meters per second, navigate slopes up to 10 degrees, and carry up to 20 kilograms on a built-in rear shelf. Pricing has not been confirmed, though industry sources estimate it could land between 20 and 30,000 United States dollars per unit. Number 2. Walker S1 by Ubtech Robotics. Ubtech's Walker S1 entered the spotlight in 2024 as a full-scale humanoid targeting industrial work. At 1.72 meters tall and 76 kilograms in weight, it is built for strength, capable of lifting up to 15 kilograms while maintaining stability. Walker S1 is already being tested at top-tier facilities including Foxconn, BYD, Geely, and the Audi FAW joint venture. It handles tasks like inspection, screw tightening, and packaging. Number 1. AgieBot A2 by AgieLab. Shanghai-based startup AgieLab revealed the AgieBot A2 in 2024, a general-purpose humanoid aimed at navigating complex indoor environments. Standing 1.69 meters tall and weighing 69 kilograms, it runs on a 700 watt-hour battery with hot swap functionality, giving it roughly 2 hours of working time. AgieBot A2 features over 40 degrees of freedom, arms with 7-axis articulation, and high-precision hands designed for delicate handling. It is loaded with stereo cameras, LiDAR, and ultrasonic sensors to safely navigate crowded or cluttered spaces. And that wraps up our countdown of the top 10 humanoid robots of 2025. OpenAI just dropped Sora 2, an AI video generator that's almost too real to believe. Overnight, the internet went insane. Sam Altman's face was deep-faked into memes, eBay invite codes were selling for cash, and the clips looked straight out of Hollywood. This thing nails physics, syncs voices, and lets anyone drop themselves into any scene. The launch feels less like an update and more like a new era of video. Now, if you rewind rewind a bit, the first Sora model came out in February of 2024. Back then, OpenAI described it as their GPT-1 moment for video. Before that, AI video was a total mess. People would melt into the background, objects would vanish mid-shot, and if you tried to make someone shoot a basketball, the ball would magically teleport into the hoop. Sora 1 was when that stopped. For the first time, it felt like video generation had rules. Objects stayed where they were supposed to stay, actions played out in order, and it wasn't just random noise anymore. Sora 2 is a whole different story. People are calling it the GPT 3.5 of video. It's not flawless, but the jump is massive. The mistakes now look like the kind of slip-ups a real person might make. A gymnast stumbles instead of glitching out of existence. A ball bounces off the rim instead of teleporting through the net. The physics engine feels like it actually understands water, weight, ice, balance, all the little details that make the world feel real. That deeper simulation of reality is the real breakthrough here, and it matters way beyond entertainment. OpenAI is aiming at a future where these systems aren't just spitting out videos, but running robots and world simulators. But let's talk about the style, because that's where people's jaws really hit the floor. Sora 2 can do cinematic realism, anime, cartoon, full dialogue scenes, you name it. It follows complex, multi-shot instructions and keeps track of what's happening across cuts. And it doesn't just generate video anymore, it does synchronized audio too. Voices, background noise, sound effects, it all comes out in sync with the visuals.
That's why we're launching Sora 2 inside the Sora app, allowing everyone to push the limits of their imagination and create in ways we never thought possible.
Some of the demos OpenAI showed off looked and sounded like actual short films, not just AI experiments. And then they added this feature called Cameo. This is where things got wild. You give Sora a short sample of your face and voice, and you're in the video. You can drop yourself into any scene, whether it's a cooking show, an action sequence, or a fantasy battle. At OpenAI's office, employees were already remixing themselves into each other's clips before launch. Sounds fun, right? But the second it hit the public, Sam Altman himself became the internet's favorite character to mess with. In less than a day, people flooded social media with Altman clips. He was shown sneaking GPUs off Target shelves, awkwardly hitting on users, starring in skibidi toilet videos, even rapping from a toilet. At one point, someone made him walk into a South Park episode and argue with Cartman. Altman took it pretty calmly. He even said, scrolling through endless memes of yourself is less weird than you'd expect. But it immediately raised a big question. Where does consent fit into this? Sure, CEOs and celebrities are used to being parodied, but regular people aren't. If anyone can throw your face into a video, even as a joke, what happens when it spreads beyond your control? That ties straight into the copyright storm this model unleashed. Within hours of launch, people were pumping out entire scenes from Cyberpunk 2077, Disney films, Naruto, Studio Ghibli, you name it. OpenAI's stance is that copyrighted content is allowed by default unless the rights holders actively opt out. That's a complete flip from how copyright usually works. Normally, you need permission first. Now, unless you step in to stop it, your work is fair game. One AI developer, Ruslan Volkov, even said if this becomes standard, copyright basically collapses. And even if companies do opt out, stopping it completely is almost impossible. Pirate data sets already scrape anything that's online. And of course, the internet went straight for the NSFW limits. Within hours, there were glossy, Sora-generated sex toy commercials, toga parties with doll-like nudity, and sim-style sex scenes. OpenAI has filters to block sexual content, violence, propaganda, and self-harm, but people were already finding loopholes. You can't make a bikini scene, but you can generate yourself smoking 10 blunts in an office. Smoking crack, though, that gets blocked. So the moderation system is inconsistent at best. All of this chaos actually overshadowed something important. Sora 2 didn't just launch as a model, it launched as a full iOS app. And the app looks a lot like TikTok. You get a feed of short, scrollable AI videos featuring whatever people generate, with or without cameos. When you sign up, it asks you to build your digital likeness. You speak a few numbers, turn your head so the app records your face and voice, and then you pick who can use it. Everyone, just your friends, or nobody. And here's the kicker. Even if someone puts you in a clip but never posts it, it still shows up on your account page, so you know it happened. Wired tested the app and said most of the early viral clips were, again, Sam Altman, him stealing GPUs, him pleading with security guards, him popping up in South Park. The voice syncing was scarily accurate, though sometimes buggy.
Look, Stan, my brand new Sora 2 account. In a week, I'm gonna have the most followers in all of South Park. Wow.
Cartman's whiny voice came out of Altman's mouth in one clip. The app also had some weird double standards. It blocked bikini videos of the Wired reporter. It refused to generate Taylor Swift impersonators or suicide attempts. But Pokemon videos, no problem. Pikachu and Bulbasaur went straight through. Now that's part of the bigger copyright issue. According to the Wall Street Journal, rights holders have to actively pull themselves out of Sora's dataset. So while Swift might get blocked, Pokemon slipped through at launch. That inconsistency has lawyers sharpening their knives already. Meanwhile, the invite system added gasoline to the hype. Every new user got 4 invite codes. By the next day, eBay had more than 20 completed sales of those codes, going for anywhere between $10.99 and $45. OpenAI quickly jumped on Discord to warn people it violated their terms of service, but the demand was already out of control. And just to give you an idea of how big this launch was, within one day, Sora was already the #3 free app on Apple's App Store, right behind ChatGPT and Google Gemini. And because the internet never disappoints, the strangest stuff went viral first. Mashable reported clips of Altman dancing awkwardly, Altman rapping on the toilet, even AI Bob Ross painting a gorilla fighting 100 men. There was also a video making fun of people eating up AI slop, which turned into literal videos of people eating messily on camera. Half uncanny valley, half eerily realistic. That's the vibe people are getting right now. But OpenAI made one thing clear in the rollout. They don't see Sora 2 as a toy anymore. This is a full platform for synthetic media. Altman himself even admitted they're worried about things like addiction, bullying, and misuse. That's why they added parental controls, team view limits, and cameo permissions. They say they're not trying to build an infinite scroll machine like TikTok. Instead, the focus is on creation, on giving people a new medium to express themselves and communicate. And this is just the start. The app is invite only for now, but Android support is coming, international rollout is planned, and an API is on the way. ChatGPT Pro users also get access to Sora 2 Pro, which pushes out even higher quality video generations. Google's quietly testing something huge called Gemini 3. Let's start with Gemini 3 because this might be Google's biggest move all year. They've been quietly A/B testing it inside AI Studio, and developers already spotted a new label buried in the code. Gemini Beta 3.0 Pro. That means it's in full internal benchmarking mode and it's looking serious. You can't actually select it yet from the dropdown, but people have seen it listed in the backend under Starter Apps. The timing's no coincidence. It's expected to go public during Google's upcoming Gemini at Work event. That's probably when we'll finally see what the model can really do. Early testers are already saying Gemini 3 absolutely dominates advanced coding, especially on front-end work. In one test, it built a full SVG of a PlayStation 4 controller from scratch. Clean lines, no major errors. That's not just text reasoning anymore, that's spatial logic and visual precision. Compared head-to-head with Claude 4.5 Sonnet, Gemini was both faster and more accurate in SVG generation. Coding speeds up, visual reasoning's better, and it's showing major progress in multimodal tasks, meaning it understands both text and visuals together far more efficiently than before. Inside AI Studio, people also noticed some subtle UI changes, like a new My Stuff section. It's basically a personal gallery where all your generated code, images, and snippets live. So yeah, Google's not just updating a model, they're building a whole workspace ecosystem around it. Gemini 3 itself actually comes in 2 versions, Pro and Flash. Pro handles complex reasoning, deeper analysis, and long tasks. Flash is tuned for speed, made for quick, responsive workflows. It's Google's way of covering both high-end developers and real-time applications. And then there are these mysterious new features popping up in the code, things labeled Deep Think and Agent Mode. Deep Think sounds like a built-in chain of thought system, letting the model run through multi-step reasoning without forgetting context. Agent Mode, though, takes it to another level. It gives Gemini browser control. That means it can literally research or perform small actions online, like filling out forms or pulling real data, on its own. Basically, Google's version of OpenAI's Agent Kit or Microsoft's Copilot Actions. As for rollout plans, Google's sticking to its classic slow burn strategy. First, they'll hand early access to enterprise users through Vertex AI, then open it to developers between November and December, and finally roll it out to consumers early 2026. Expect it to show up first in Android 17, Google Search, Chrome, and Workspace. That's a staggered release meant to stress test everything before it hits the mainstream. If all goes according to plan, Gemini 3 could push Google past 500 million active users by the end of the year, putting it head-to-head with OpenAI's GPT-5 and Musk's Grok 4. What's interesting now is that these models aren't just fighting over accuracy anymore. They're fighting over ecosystems. Google's weaving Gemini into every corner of its platform: Chrome, Pixel phones, Workspace, while OpenAI is turning ChatGPT into a full platform with its apps, SDK, and agent kit. Now, while Google's doing that, something completely different is happening in open source. A developer just dropped Ovi, an independent text-to-video model based on WAN 2.25b, which is a diffusion-based backbone. It can create 5-second videos at 24 frames per second in 720p, complete with synced speech. So you type a line of dialogue, the AI builds a character, animates it, and makes it talk.
It is the age of Ovi. I will never let that happen.
It supports both text to video and image to video, so if you give it a static portrait, it can literally animate the person's face and lips to match your dialogue. It's all built on Comfy UI, the same open framework used by Stable Diffusion artists. You just install a new plugin called Comfy UI Ovi, and you're set. It runs either locally or on your own server. Setup's pretty simple if you're used to command line tools. You activate your virtual environment, open the custom nodes folder, clone the GitHub repo, then install dependencies with pip install -r requirements.txt, restart Comfy UI, drop in the model weights, the OV11 BBF16 tensor and audio files, and it's ready to roll. Once it's loaded, you'll see an Ovi engine loader node. You connect it to your model file, select a text encoder like UMT5 FP16, then link it all together: attention selector, best one Sage attention, latent decoder, and video generator. Type your prompt, hit generate, and it'll create a short talking video. If you're using image to video, load your image as the first frame, then type what you want it to say. For dialogue, you just wrap your text in brackets labeled S and E, like S, hey, welcome to the show, E. That's how the AI knows what to speak. It then outputs a 5-second clip with perfectly synced audio and video. Frame rate's 24, rendering takes about 2 minutes for 50 sampling steps, and the final output comes with both sound and visuals baked in. Now, there are still limits. You can't pick specific voices or clone them. It picks a random one each time. You can't match tone across clips, and videos are locked at 5 seconds, no longer. So if you chain multiple clips, your character might sound slightly different in each. It's early, but it's a big step. This is the first fully local model that can generate both video and audio in one pass. It's like a smaller open source version of Google's VEO 3, only it runs on your own setup. Artists are already testing it. One used Quinn Image Edit to design a recurring character, then applied Lightning 4-step LoRa to build multiple clips of that same character doing different actions. They stitched everything together into one mini film, rough, but proof of concept. You can see where this is heading: AI native filmmaking. Meanwhile, OpenAI took a different turn this week. They went full meta. Their new study measuring the performance of our models on real-world tasks basically measures how often AI beats humans at their jobs. The team used a framework called GDP-VEL to compare AI and human workers across 9 major United States industries. They measured quality and output speed side by side. The result? AI matched or outperformed humans in about 48% of all tests, nearly half. Some roles got wiped. Retail clerks and cashiers lost to AI over 80% of the time. Sales managers and shipping clerks were close behind. Even editors, programmers, and private investigators, around 70 to 75% of the time, AI came out ahead. Even social workers, surprisingly, lost about half the trials. The jobs that held up? Creative and leadership roles. Stuff where human judgment and emotion still matter. Film directors, journalists, and producers only lost in about 1/3 of tests. So the edge isn't gone yet, but the line's getting thinner. Sam Altman spoke about this recently, and he didn't sugarcoat it. He said customer support jobs, phone calls, chat reps, are basically done. He expects AI to fully take over those soon. His longer-term prediction? Around 40% of all jobs could eventually be automated. That number isn't pulled from thin air. It's based on OpenAI's internal model data. He even went further, saying that AI could eventually replace the CEO role, including his own. In his interview with Axel Springer's Matthias Dopfner, he literally said he'd be enthusiastic the day an AI runs OpenAI better than he can. He sounded more fascinated than worried, which tells you how far ahead he's thinking. But not everyone's that bullish. IBM's CEO Arvind Krishna said at SXW that AI won't replace people across the board. He disagreed with Anthropic's Dario Amodei, who predicted that 90% of code could be written by AI within 6 months. Krishna said the number's closer to 20 to 30% tops. Sure, some repetitive tasks fit perfectly for AI, he said, but complex human judgment isn't going anywhere yet. Either way, the pattern's clear. This race isn't just about smarter chatbots anymore. It's about who can build the first fully autonomous ecosystem where AI handles everything, reasoning, action, and feedback, without needing a human in the loop. That's where things stand. We're watching 3 fronts evolve at once. Google pushing next-gen multimodal AI, open source developers bringing video generation to local machines, and OpenAI tracking how fast humans are getting overtaken. Google just launched VEO 3.1, and it's a big upgrade. The clips look more cinematic, the motion flows seamlessly, and the physics finally add up. Alright, let's start with Google, because VEO 3.1 just dropped, and it's a serious step up. After weeks of leaks, Google officially unveiled its next generation AI video model, now available inside Flow and through the Gemini API. The jump in control is massive. The clips look more cinematic, motion feels smoother, and the physics finally make sense. For the first time, you can generate full audio directly inside the tool. Dialogue, ambient sound, even emotional tone, all synced automatically. Before,
the city always got a story. Just gotta listen.
Or you had to manually layer sound in post, now it's built right in. For companies producing ads or training videos, that's a huge time saver. VEO 3.1 lives inside Flow, Google's AI filmmaking platform, but it's also tied to the Gemini API for developers, and soon will be part of Vertex AI for enterprise users. Pricing didn't change, 40 cents per second for the standard version, 15 cents for the fast one. No free tier, pay only for what's generated. Output options stay at 720p or 1080p, 24 frames per second, and you can stretch clips up to about 2.5 minutes using the new extend feature that continues from the last frame of the previous video. Great for building longer, connected scenes. Control runs deep here. You can feed it text prompts, images, or video clips, add up to 3 reference shots to lock in visual style, and even interpolate between start and end frames for seamless motion. They've added insert and remove tools to drop or erase objects mid-scene, though those are still rolling out on the API side. Large clients can now maintain product consistency across campaigns, move one logo or product photo, and VEO 3.1 keeps it identical in every shot. Flow also lets you tweak scenes without regenerating the entire thing, which turns what used to be a long rebuild into quick creative editing. Every clip carries Google's invisible Synth ID watermark and passes copyright and privacy filters before it's stored. Temporarily, for 2 days only unless you download it. Feedback has been mixed. Some creators love the control, others still feel OpenAI's Sora 2 delivers more natural realism. Matt Schumer from Otherside AI called VEO 3.1 less impressive visually than Sora 2, but praised its editing depth. 3D artist Travis Davids liked the sound system, yet criticized the lack of custom voices and the short 8-second limit on bass clips. Others ranked it as excellent usability, still behind Sora in realism. Basically, Google nailed functionality, but the realism race is still tight. Now, while Google focused on film-grade visuals, Anthropic went the opposite way. Leaner, faster, and cheaper. Claude Haiku 4.5 just landed, and the efficiency jump is wild. Think of it as a compact version of Claude Sonnet 4.5, their top reasoning model from 2 weeks ago, but running twice as fast and costing 1/3 as much. Not long ago, Sonnet 4 was their flagship. Now that level of coding power fits inside a lightweight Haiku model at just $1 per million input tokens and $5 per million output. Despite being smaller, Haiku 4.5 matches Sonnet 4 in several benchmarks and even beats it in real-time tasks. Anything involving direct computer interaction, coding, automation, chat support feels much snappier. Anthropic even encourages users to pair models. Sonnet 4.5 can split a big project into smaller steps, then assign those pieces to multiple Haiku 4.5 instances running in parallel. It's built in multi-agent orchestration, turning one request into a small collaborative network. Performance numbers back it up. On SWE Bench, verified, coding results are on par with much larger systems, and response latency is impressively low. It's already available through the Claude API, Claude Code, Amazon Bedrock, and Google Cloud Vertex AI. So if you've been using Haiku 3.5, switching over takes just a quick endpoint update. Safety's been another highlight. Anthropic ran an extensive set of alignment tests and found Haiku 4.5 showed fewer misalignment issues than Sonnet 4.5 or Opus 4.1. In other words, it's their most stable model so far. It earned an AI Safety Level 2 certification, slightly looser than the Level 3 used for their top frontier systems, showing it's safe enough for wide release. They even put it through Severin stress tests, chemical, biological, radiological, nuclear, and found minimal risk potential. Their public system card breaks down every dataset and benchmark use, including SWE Bench, Terminal Bench, Tau2 Bench, AIME, OSWorld, and MMLMU. This balance between frontier power and lightweight efficiency says a lot about where the industry's headed. Anthropic's approach lets you mix models like components. Sonnet handles reasoning, Haiku handles execution. It's less about one massive model and more about orchestration among smaller, specialized ones working together in real time. And then there's Kong, which just entered the scene with something that could totally reshape how developers build AI agents. It's called Volcano, and it's already turning heads. Essentially, Volcano is an open source toolkit that lets anyone create smart, customizable AI assistants with just a few lines of code. Here's why developers are hyped. Older frameworks like LangChain or Haystack were designed before a key standard called MCP, Model Context Protocol, even existed. MCP lets models communicate directly with tools, APIs, and databases using one shared format. Those older frameworks had to retrofit it later, while Volcano was built for it from the start. That makes integrations much cleaner, faster, and far less buggy. At the API Summit in New York, Kong's CTO, Mark Palladino, did a live demo that blew everyone away. He asked the crowd to scan a QR code, and instantly an AI agent built with Volcano grabbed people's names and locations, then placed over 900 coffee orders at nearby shops, all running on just 15 lines of code. The audience watched it happen in real time. Because Volcano is MCP native, it works seamlessly with Anthropic, OpenAI, AWS, Azure, and Google Cloud models. It can even combine them mid-workflow using Claude for reasoning, then switching to a faster model for execution, automatically picking the best one for each task. Developers can spin up smaller sub-agents that other agents reuse, effectively creating mini AI ecosystems that manage themselves. Kong's CEO, Augusto Marietti, also announced that their AI gateway is getting major MCP upgrades. Now, any API you manage through Kong can instantly be turned into an MCP server, no manual setup needed. They added unified security via a new MCP OAuth plugin and introduced an AI integration composer that helps developers connect smart APIs like building blocks. You build, secure, and deploy within the same environment. Volcano is fully open source, and Kong is already inviting contributors to expand it. Even at this early stage, it's one of the most polished, straightforward frameworks for agent development available. It takes the overly complex LangChain graphs and distills them into a clean, simple TypeScript flow that actually works the way you expect. That's the full rundown for this week's wave of launches. Google pushing cinematic AI film tools, Anthropic streamlining intelligence into smaller packages, and Kong rewriting the rules of agent creation. Microsoft just dropped its first ever image generator built completely in-house. Starting with Microsoft, because this one really caught everyone off guard, Microsoft AI has launched its first text-to-image model developed entirely internally, and it's called MAI Image 1. Until now, Microsoft leaned heavily on partners like OpenAI for generative models, but this time they went solo and nailed it. The model already sits among the top 10 on LM Arena, where humans rate image quality in live comparisons. That means it's competing directly with heavyweights like Midjourney and Runway, and actually holding its own. MAI Image 1 is part of Microsoft's growing internal lineup that started with MAI Voice 1 and the MA1 preview model. This one extends that family into visual generation. The company says its goal was simple: make images that feel real, not like the recycled AI art we've all seen 1,000 times. They spent months refining data selection, focusing on data sets that mirror what professional creators actually use. They even collaborated with real artists to ensure the model's visual style stays natural. Early testers say MAI Image 1 stands out for its realism, especially when it comes to complex lighting, realistic reflections, and natural environments. It's also quick. Microsoft designed it for what they call rapid iteration, meaning you can generate multiple high-quality images within seconds and pass them straight to editing tools without slowing your workflow. Basically, you create fast, refine fast, and keep moving. Right now it's being tested publicly on LM Arena, where users can prompt it, vote on results, and see it side by side with other models. This helps Microsoft fine-tune safety guardrails, something they've been improving since launching Copilot and Bing Image Creator. Once this testing wraps, MAI Image 1 will be integrated directly into Copilot, Bing Image Creator, and eventually Microsoft 365. So every Windows user will soon have a native image generator sitting inside their apps. The company hasn't shared the technical details, no architecture, no parameter count, but from how it performs, it's clearly optimized for low latency and interactivity, not massive offline rendering. That means it's tuned for quick prompts and consistent visual quality, probably using a tight token-to-pixel pipeline that avoids the style collapse problem where every image starts looking the same. But here's the bigger takeaway: Microsoft's clearly shifting strategy. For years, they've been OpenAI's biggest backer, but now they're building independent models, experimenting with Anthropic systems, and rolling out internal AI under their own name. MAI Image 1 marks a real turning point. It shows Microsoft doesn't just want to fund AI innovation, they want to lead it. If the rollout goes smoothly, it could easily become the default creative tool for hundreds of millions of people who already use Windows every day. Now, while Microsoft's chasing control and precision, Google's going the opposite way, making AI creation effortless. Instead of launching another flashy app, they quietly built their creative model right into search. It's called Nano Banana, and yes, the name's weird, but the execution is brilliant. Nano Banana has been around for a while inside Gemini and a few other Google tools, but this is the first time it's been fully integrated into search through Lens and AI mode. You open Lens, tap the yellow Create button, the one with the banana icon, and you can start generating or editing images right inside the search flow. No downloads, no extra apps, just type what you want and get results instantly. It's rolling out first in the United States and India, supporting English for now, but it'll expand globally soon. Google isn't hyping it with a big marketing push either. It's more of a quiet update that makes search feel more alive. And it works surprisingly well. Nano Banana handles lighting and realism beautifully, keeps people recognizable after edits, and automatically watermarks everything with Synth ID, both visibly and invisibly, so AI-generated content is properly tagged. The best part is how smooth it feels. It's fast, lightweight, and polished for something baked straight into search. Google isn't trying to compete directly with image tools like Midjourney. They're just weaving creativity into what billions of people already do every day, and that might actually be more powerful than any standalone product launch. But the biggest shock this week didn't come from the West. It came from China. Ant Group, the fintech giant behind Alipay, unveiled a monster called Ling1T. The name literally means 1 trillion, and that's how many parameters it packs. It's open source, massive, and designed to challenge OpenAI, DeepSeek, and even Google's Gemini series on reasoning, math, and code generation. Ant describes Ling1T as a general-purpose model, a kind of digital hybrid between a mathematician, a coder, and a logician. What's surprising is that it's open source. That's nearly unheard of at this scale. Western labs like OpenAI and Anthropic keep their biggest models locked away, but Ant flipped that idea completely. They're betting that transparency and collaboration will move AI forward faster than secrecy ever could. On performance, Ling 1T isn't just holding its own, it's competing directly with the best. It scored about 70.4% accuracy on benchmarks like Live Codebench and the American Invitational Mathematics Examination. That's right in line with Gemini 2.5 Pro and ahead of both DeepSeek and GPT-5 Main. Each test used more than 4,000 output tokens, showing how deeply the model can reason through complex problems. Ant Group says the focus wasn't just scale, it was consistency and logical accuracy in real-world conditions. They claim Ling 1T demonstrates better reasoning stability than both open and closed alternatives, and since this is actually their second trillion-parameter model after Ring 1T Preview, which they called the world's first open-source thinking model, it's clear they're all in on open innovation. What's happening here is a real shift in China's approach to AI. Instead of building models solely for domestic use, they're competing globally and inviting collaboration. Ant Group is positioning itself as the open alternative in a world of closed systems. If Ling 1T keeps up this pace, it could push the whole AI race toward a more community-driven future, where trillion-parameter systems are shared instead of hidden behind expensive API. And just when everyone was digesting that, Google pulled another move, this time changing how voice search itself works. They launched something called S2R, short for speech to retrieval, and it quietly replaces one of the oldest parts of voice technology. Every voice assistant you've ever used, Siri, Alexa, Google, follows the same basic formula. Listen to your question, convert your speech into text, then search for an answer. But that transcription step is where everything can fall apart. A single misheard word can completely ruin the query. So Google decided to remove it altogether. With S2R, your voice isn't turned into text anymore. It's converted into something called an embedding, a mathematical representation of meaning. That embedding is compared directly with Google's index, matching ideas instead of literal words. The result? The system doesn't care how you phrase the question, it just understands what you meant. S2R uses a dual encoder setup. One model processes your voice, another encodes web documents, and the two are matched by meaning. It streams audio in real time, retrieves results instantly, and sends them through Google's normal ranking engine. In tests across 17 languages, it outperformed traditional speech-to-text pipelines and got close to human-level comprehension. Google even released a public dataset for developers called Simple Voice Questions, hosted on Hugging Face. It covers 26 locales in 17 languages, with recordings from quiet rooms, busy streets, and even TVs playing in the background. It's part of a new benchmark suite called MSC, the Massive Sound Embedding Benchmark, meant to standardize how we measure AI systems that work with sound. So next time you talk to Google and it just gets you instantly, that's not coincidence. That's S2R handling your voice directly through meaning, skipping text altogether, no transcription errors, no misheard names, just intent, straight to results. AI might have just found a way to fight cancer. Google DeepMind built a system that reads human cells like text, and it uncovered a hidden method to make tumors visible to the immune system. Google's AI that might have just found a way to fight cancer. They call it Cell 2-Sentence Scale 27B, or just C2S scale for short. It's a massive 27 billion parameter foundation model built on the Gemma family, Google's open source model lineup that's already been pushing boundaries in reasoning and multimodal understanding. But this time, they pointed all that power towards something completely different: single cell biology. In simple terms, the model reads and writes the biological sentences that make up life inside every cell, translating raw gene activity into a language AI can reason with, and the results have been wild. In collaboration with Yale University, DeepMind used this model to search for new ways to make cancer cells visible to the immune system. See, one of the biggest problems in cancer immunotherapy is that some tumors go what scientists call cold. That means they basically hide from the immune system. The body can't detect them because they don't show enough of the right surface signals, the ones that tell immune cells, hey, I'm a problem. Turning those cold tumors hot, meaning visible and attackable, is a key goal for researchers all over the world. So here's where things get interesting. DeepMind gave its new 27 billion parameter model a task: find a compound that would only activate an immune signal under very specific conditions. Only in cells that already show low levels of a protein called interferon, which acts as a kind of immune alarm. Smaller models couldn't pull this off, but scaling up changed everything. C2S scale could reason through those subtle biological contexts like a scientist would. To run the experiment, Google's researchers built what they called a dual context virtual screen. One environment had patient-derived tumor samples that still had immune activity going on. The other was stripped of any immune context, just isolated cancer cell lines. The AI then simulated the effect of over 4,000 drug candidates across both environments, asking which ones would only enhance immune visibility in the first scenario. The idea was to find something that would boost antigen presentation, basically the signal that helps immune cells detect cancer, but only in the right setting, where it's safe and biologically relevant. The output from the model was fascinating. Around 10 to 30% of the hits it predicted were already known drugs from previous studies, which proved it wasn't hallucinating. But the rest were entirely new candidates, substances that had never been linked to this immune effect before. And right there, among those unexpected results, one name stood out: silmitasertib, also known as CX4945, a kinase CK2 inhibitor. CK2 isn't new to science. It's a protein tied to cell growth, signaling, and even parts of the immune system. But no one had ever shown that blocking it could help expose hidden tumors. The model predicted that combining silmitasertib, a CK2 inhibitor, with low-dose interferon would do exactly that: turn cold tumors hot. When DeepMind and Yale tested it in human neuroendocrine cells, data the AI never saw during training, the results matched perfectly. Silmitasertib alone had no effect, interferon alone barely moved the needle, but together they triggered about a 50% jump in antigen presentation, making the cancer cells far more visible to the immune system. That's an early stage result, but a huge moment for AI in medicine. The model didn't just recall known data, it generated a brand new testable hypothesis that held up in living cells. Smaller models couldn't even detect the context split that made it work. And instead of keeping it private, Google open sourced everything, the weights, code, and docs, on Hugging Face and GitHub under CC BY 4.0. Trained on over 57 million cells from 800 datasets using TPU5, it's now a global tool for researchers to build on. As Sundar Pichai put it, this could open a new pathway for cancer therapy once more testing is done. In short, it's not about curing cancer overnight. It's about creating a faster, AI-driven pipeline for real biological discovery. The same Gemma architecture that powers language and reasoning in humanoid systems is now decoding cellular behavior, a true language model for life itself. While Google's AI was busy helping scientists fight cancer, the rest of the tech world went into total meltdown over something completely different: GPT-6. It all started when CNBC aired an interview with analyst Mark Mahaney from Evercore ISI, who confidently claimed that OpenAI's next model, GPT-6, would launch before the end of 2025.
ChatGPT-6 is coming out before the end of the year, and I just think we're going to see these step function improvements in the product. If you do that, and you're in the OpenAI ecosystem, you're okay in terms of vendor financing.
Within hours, social media went wild. Posts from @AI-Leaks and News and Testing Catalog exploded across X, shouting, "Breaking! GPT-6 is dropping in less than 3 months." Even OpenAI investor Brad Gerstner's name got pulled into the chaos, fueling the hype even more. Then came the twist. An OpenAI engineer known online as Rune, @TCZL, stepped in to crush the rumor, saying flat out that GPT-6 isn't shipping this year. What users are actually seeing right now is still GPT-5, just in different forms. There's GPT-5 Auto, which swaps between reasoning and instant models depending on your query, and GPT-5 Instant, a stripped-down, faster version. So even if it feels new, everything you're using today is still running on GPT-5 tech. But behind the scenes, OpenAI is quietly building something massive. Multi-billion-dollar hardware deals are already locked in. They've partnered with AMD on a 6-gigawatt GPU rollout and with Broadcom to co-develop custom AI chips that will eventually push over 10 gigawatts of computing power between 2026 and 2029. So, no GPT-6 yet, but the foundation for it is already being built on a scale we've never seen before. Officially, Sam Altman has only said two things. GPT-6 will be significantly better than GPT-5, and GPT-7 will take it even further. He's also hinted that these next-gen models will have scientific discovery abilities, which lines up perfectly with what Google's doing with DeepMind's biological AI. The next generation of AI won't just chat, it'll help uncover real-world breakthroughs. Still, the wildest part of the rumor mill claims GPT-6 will come with long-term memory and continuous learning. Basically, an AI that remembers you, learns from you, and improves on its own without retraining. Most of that talk comes from an MIT paper called Self-Adapting Language Models, SEAL, describing systems that can literally edit their own neural weights. There's no proof it's tied to OpenAI, but the timing and overlap have people convinced. If that ever becomes real, GPT-6 wouldn't just be another upgrade, it would be the first AI that actually evolves with you. For now, it's still theory, but with the infrastructure already rolling out, the next leap could hit as early as 2026. OpenAI just made a bold move straight into Google's territory, and this time it's not about models or search engines. They've launched ChatGPT Atlas, a full AI browser that turns the entire web into one big conversation with ChatGPT sitting beside you. It's their biggest step since ChatGPT itself, and it's already shaking up how people think about browsing. The reveal happened on October 21st, streamed live with Sam Altman leading the demo. He opened by saying Atlas isn't just another add-on, but a complete rethink of what a browser should be. His exact words were, "Tabs were great, but we haven't seen real browser innovation since then." That line captured the whole idea. Atlas isn't about search bars or 10 open tabs anymore. It's about telling your browser what you want and letting the AI handle everything else. Atlas launched globally on macOS with Windows, iOS, and Android versions rolling out soon. The advanced agent mode is exclusive to Plus and Pro users for now, and that's where it gets powerful. You can literally ask it to perform tasks. Need to book a flight, clean up a document, or order ingredients for a recipe? Just tell it. During the demo, Atlas pulled up a meal recipe, went to Instacart, grabbed all the ingredients, and completed checkout, all on its own, while the user simply watched. The people behind this are serious veterans. Ben Goodger, one of the original Chrome and Firefox engineers, was part of the team, along with designers from Apple and Mozilla. Altman described Atlas as the beating heart of ChatGPT, saying this is how OpenAI wants people to experience the internet, a chat interface fused with the open web. At first glance, it still looks like a regular browser. There's a URL bar, tabs, and navigation buttons. But once you start using it, you realize it's something different. The web itself becomes part of the chat. Open a result and the screen splits, the page on one side, ChatGPT on the other. You can summarize the page, rewrite text, compare products, or ask questions about what you're reading. The feature that makes this possible is called Cursor Chat. You highlight text in an email or article, and ChatGPT instantly rewrites or explains it right inside the page. Atlas also remembers what you do. It tracks what you've searched for, what you've read, and what projects you're working on, then uses that information to personalize your experience. If you were comparing phones last week, it might show updated deals this week. You can clear or manage these memories at any time, or use incognito mode to start fresh. Everything stays under user control, including which sites ChatGPT can see or interact with. This agent mode isn't coming out of nowhere. OpenAI has been building toward it for more than a year. Their early operator experiments showed ChatGPT clicking around a computer for you. Atlas is the next step, a full functioning browser built around that concept. It's basically an evolution of ChatGPT Agent, the version that could perform complex tasks like online shopping or file editing, but now it works on live websites, not simulations. Performance-wise, people are impressed. Altman said during the live stream, this is just a great browser overall. It's smooth, quick, really nice to use, and that's key. AI browsers can't just be smart, they have to feel fast and natural, as fluid as Chrome or Safari. Atlas seems to manage that. This project has been in the works since mid-2024 when OpenAI teased something called Search GPT, an experimental AI search engine that never launched on its own. Those ideas eventually merged into Atlas. The timing couldn't be better. In the past year, AI browsers have become the next big thing. Perplexity launched Comet, a conversational answer engine that summarizes videos, manages tabs, and even shops for you. Oprah released Neon, Brave added its own AI layer, and Google started integrating Gemini into Chrome. Atlas enters right into that race for the future of browsing. The launch had an instant impact. Alphabet's stock dropped about 1.8% after Atlas went live, a sign that investors see this as a genuine threat. Google Chrome still controls about 72% of the global market, but OpenAI isn't just chasing that market share, it's trying to redefine what a browser even is. Instead of typing, clicking, and switching between pages, Atlas keeps ChatGPT as your constant co-pilot, learning from your habits and context as you go. The demo showed Atlas summarizing entire web pages, comparing products side by side, and analyzing spreadsheets in real time. The idea is to keep users on one page instead of constantly jumping between tabs. For example, if you're booking flights, you can ask Atlas to filter options by weather, price, or stopovers, and it updates right inside the site. Privacy was one of the main topics during the event. OpenAI says Atlas gives users total control over what the AI sees. You can block specific sites, clear browsing data, or disable memory completely. There's also an incognito mode that automatically logs you out of ChatGPT so nothing gets saved. Atlas can't run code, download files, or access your local storage. It even pauses itself automatically on sensitive pages like banking sites and asks for permission before acting. For families, Atlas includes parental controls borrowed from ChatGPT with new options to turn off memory or agent mode for kids' accounts. That level of customization helps OpenAI avoid the privacy concerns that hit earlier AI systems. The bigger picture here is strategy. OpenAI is building what Altman calls a super assistant, one that follows you everywhere, desktop, mobile, web, and now directly inside the browser. It even connects with the massive WhatsApp user base that's been using ChatGPT this year. Over 50 million people have tried ChatGPT through WhatsApp, but that integration ends on January 15th, 2026, due to new WhatsApp policies. OpenAI is asking users to link their accounts before that date so their chat history transfers over. Afterward, ChatGPT will live only through iOS, Android, the main web version, and Atlas. They're using this transition to push Atlas as the next step. Everything users had on WhatsApp, voice chat, file uploads, deep research, will now exist directly in Atlas. Once linked, your number and chat history appear in your ChatGPT profile, creating one continuous conversation across devices. Still, not everyone is excited. Some researchers warn that AI browsers could start shaping what users see instead of just assisting them. Patty Harrington from Forrester told the Associated Press that if a browser learns too much about you, it might start filtering your experience without you realizing it. Others are worried about advertising. If OpenAI decides to use behavioral data for ads, it could challenge Google's 90% dominance in search advertising. Analysts at D.A. Davidson believe Atlas could mark the start of OpenAI entering that market. Regulators are already paying attention. A European Broadcasting Union study done with the BBC found that 45% of AI-generated answers across major platforms contained at least one serious factual mistake, and over 80% included minor inaccuracies. The study tested 14 languages and covered ChatGPT, Gemini, Copilot, and Perplexity. In one test, ChatGPT still referred to Pope Francis as alive months after his reported death, showing how easily AI systems can spread errors. The EBU's media director warned that when people don't know what to trust online, they start trusting nothing, which can damage democratic participation. Despite the criticism, momentum is growing. ChatGPT now claims over 800 million users worldwide. A survey from the Associated Press found that 60% of Americans, and nearly 3/4 of those under 30, use AI to find information at least occasionally. That's a massive audience ready for a browser built around AI. Other companies like Comet, Neon, and Brave have entered this race, but Atlas feels different. It doesn't just summarize, it acts, navigating the live internet for you. Since Chrome's launch back in 2008, web browsers haven't really changed. Atlas might finally break that pattern. So, what do you think about OpenAI stepping into the browser world? Is this the future of the internet or just another ambitious experiment? Google just revealed something wild, an AI system called VISTA, and it's changing what video generation even means. This thing doesn't retrain, doesn't fine-tune, and doesn't wait for updates. It simply learns from its own mistakes every time you use it, Each run makes it smarter, cleaner, and more cinematic than before. And in Google's internal tests, VISTA actually beat VEO 3, their previous flagship video model, in 60% of comparisons. That's not just progress, that's evolution happening in real time. So here's what's really going on. VISTA takes your idea, a sentence, a paragraph, whatever you give it, and turns it into a structured plan before it even starts generating anything. It breaks that idea into scenes and assigns each one 9 specific traits. How long it lasts, what type of scene it is, who's in it, what they're doing, what they're saying, what the world around them looks like, how the camera moves, what sounds play in the background, and the overall mood. Instead of guessing what the model might output, VISTA builds a full roadmap and then runs multiple candidate videos through a kind of tournament. Each video competes head-to-head in pairs, and the winners move on. Before the judging begins, VISTA writes something called probing critiques. These are short analyses explaining what worked, what broke, and what the AI noticed about the scene's structure, visuals, and logic. It's not judging blindly. It's thinking through each result before making a call. When a round finishes, the top video doesn't just win, it moves to a second stage where a panel of specialized judging agents takes over. There are 3 categories of judges: visuals, audio, and context. And each one has 3 roles: a normal judge that scores performance, an adversarial judge that hunts for weaknesses, and a meta judge that combines both opinions into a final decision. The visual team looks for image clarity, motion stability, focus, and temporal consistency, basically whether it looks real and natural. The audio judges analyze sound quality, synchronization, and unwanted artifacts. The context judges handle logic. Is the story coherent? Do the actions make sense? And do transitions feel smooth? Once that's done, VISTA calls in its main brain, the deep thinking prompting agent. This is the part that actually rewrites the prompt. It doesn't just tweak a few words, it goes through 6 reasoning steps: identifying what failed, defining what success looks like, checking for missing detail, deciding whether the problem came from the model or the prompt, finding vague or conflicting language, and finally proposing concrete improvements. Then it generates new prompts, makes new videos, and the loop repeats. By default, it goes through 5 total cycles, 1 initial round, and 4 self-improvement loops. Each cycle samples 5 prompts, creates 3 variants of each, and produces 2 videos per prompt, making about 30 videos per iteration. It's a lot of computation, but every loop brings visible improvement. On benchmarks, the results speak for themselves. VISTA was tested on a single scene dataset of 100 prompts and a multi-scene internal dataset with 161. Compared with direct prompting, where you just feed a raw text into VEO, VISTA's refined approach produced far better videos. By the 5th iteration, it won 45.9% of single scene tests and 46.3% of multi-scene ones, a margin more than 30 points higher than the baseline. They also compared it to other optimization tools like Visual Self-Refine, Google Cloud's rewrite system, and VPO. Those alternatives gave inconsistent results. Some even got worse with more iterations. Visual Self-Refine started strong but quickly plateaued, VPO bounced around, and rewrite was unpredictable. VISTA, on the other hand, kept getting better with every loop, proving it was actually learning instead of just getting lucky. To double check, 5 professional prompt engineers compared VISTA's results with those from the best competing models after 5 iterations. VISTA won 66.4% of those matchups. When experts rated full optimization runs on a 1 to 5 scale, VISTA averaged 3.78, while the next best scored only 3.33. Breaking it down further, the visual quality jumped from 3.36 to 3.77, and audio quality from 3.21 to 3.47. The differences might look small, but they add up when scaled across entire video sequences. And even though individual preferences varied, some evaluators valued realism, others smoothness or sound, they consistently picked VISTA's outputs as the best. Behind the curtain, it runs on Gemini 0.5 Flash as the multimodal reasoning engine and VEO 3 as the video generator. Even when they swapped VEO 3 for the weaker VEO 2, VISTA still boosted quality, 23.8% win rate for single scene and 33.3% for multi-scene tests. That shows the framework itself is doing the heavy lifting, not just the generator. Each iteration uses about 0.7 million tokens on average, mostly during the tournament phase because every video input is over 2,000 tokens. It usually generates around 28 videos per loop. Sure, it's compute heavy, but the more resources you give it, the better it performs. When researchers pushed VISTA through 20 iterations, it just kept improving, while other methods plateaued. Even a lighter version running on the multi-scene dataset continued climbing long after the competitors stalled. They also tested what happens when you remove pieces of the system. Without the scene planning, the visuals lost consistency. Without the tournament stage, results got unstable. With only one judge, the logic fell apart. And removing the deep thinking agent stopped progress entirely. Every single part of VISTA's design matters. One of the most impressive results was how it handled hallucinations. VEO 3, like most video models, often adds things that weren't requested. Random text overlays, unwanted music, or objects appearing and disappearing mid-shot. VISTA cuts this down dramatically by enforcing strict planning rules and applying penalties if those rules are broken. If captions appear when none were asked for, the video loses points. If characters move unrealistically or objects vanish, that clip is downgraded. The end result is cleaner, more coherent footage. VISTA also got much better at following detailed instructions. In one test, the researchers asked for a factory scene with a blade battery on a conveyor belt, a yellow industrial robot, and a screen showing a yield percentage in simplified Chinese. Normal prompting missed the details completely. VISTA delivered everything perfectly, the layout, robot, and text. In another example, they requested gremlins riding a wooden roller coaster moving forward while the camera tracked backward. Standard prompting messed up the directions entirely. VISTA fixed it, producing a shot that looked logical and physically correct. This approach is part of a larger movement in AI research known as test time optimization. Instead of building larger models or retraining them endlessly, the focus shifts to using computation at inference, letting the system refine itself while it runs. OpenAI has been exploring it for reasoning models, and now Google's applying the same principle to video. According to the research paper, VISTA is the first black box test time optimization system for text-to-video generation. Earlier approaches either required internal model access or focused on narrow goals like object detection or safety. VISTA unifies all of it, visual, audio, and contextual refinement in one continuous feedback loop. There are still limits, of course. The judging agents depend on multimodal LLMs, which can introduce bias. Human evaluations help, but they're expensive and can't scale infinitely. Some quality metrics assume a specific cinematic style that might not apply to every project. And VISTA's success still depends on how good the base models are. It can't surpass their fundamental capabilities. Still, the impact is undeniable. VISTA outperformed VEO 3 in 60% of trials, won 66% of expert comparisons, and showed steady improvement without retraining. It followed instructions more accurately, produced smoother multi-scene sequences, synced audio and video seamlessly, and dramatically reduced hallucinations, all during test time. But if this kind of system keeps evolving, it could completely change how we make video content. Production could become faster, cheaper, and far more accessible. Each run becomes its own lesson, every iteration a step toward perfecting the craft automatically. So maybe this isn't just a better AI, maybe it's the start of self-improving filmmaking, where the machine learns to direct itself, scene after scene. OpenAI is reportedly working on a groundbreaking AI music model trained with the precision and emotion of Juilliard musicians. The OpenAI, this one could completely change creative work. The company is reportedly developing a next-generation AI that can compose original music from both text and audio prompts. You could type something like "slow piano in the rain" or upload a short vocal line, and the model would build a full instrumental arrangement around it in seconds, complete with harmony, rhythm, and mood. Insiders say OpenAI even collaborated with students from Juilliard to annotate professional music scores for training, giving the system detailed data on how real musicians interpret emotion, phrasing, dynamics, tempo shifts, all the subtle touches that make performances feel alive. This isn't just about recreating sound. It's about teaching AI how to understand musical expression itself. OpenAI already explored this space years ago with Jukebox, a model that could mimic artists and blend genres, but this new project seems much more refined, designed to fit seamlessly into their ecosystem of tools. Imagine creating a short film in Sora and instantly having ChatGPT generate a perfectly timed soundtrack to match it. That kind of workflow could redefine how independent musicians, filmmakers, and YouTubers produce sound. There's still no official release date, but internal testing is reportedly deep in progress. And considering OpenAI's valuation recently surpassed $500 billion, this definitely isn't a small side project. They are clearly building music generation into the core of the creative stack, something that could make professional-grade composition available to anyone with a good idea and an internet connection. Meanwhile, a totally different kind of innovation has arrived on the Mac. The browser company just released Dia, a new AI-driven browser that's now free to download for anyone using an Apple Silicon Mac. It's minimal, fast, and built around a single idea, giving users an intelligent assistant that can actually think across multiple tabs in real time. Dia lives directly inside a normal tabbed interface, but is constantly aware of what's on your screen. It can summarize long articles, compare listings, draft messages, or polish text without interrupting your work. The magic is its contextual reasoning. If you have two Airbnb pages open, Dia instantly compiles a neat side-by-side comparison with prices, amenities, reviews, and cancellation terms. It can also pull quotes from PDFs, reply to short customer messages, or even warn you when you're about to make a questionable purchase. Because the AI needs access to your tabs, privacy is treated as a priority. You get full control over which pages it can read, and sensitive sites like banking or medical portals are automatically blocked. The timing couldn't be better. Apple just started rolling out its own on-device AI features for M-series Macs, and browsers like Arc, Brave, and Opera are experimenting with assistants. But Dia's approach stands out. Instead of just adding a chatbot, it focuses on reasoning across everything you're already looking at, the entire workspace, not just a single page. Right now, Dia is available only on M1 and newer Macs, but a Windows version is already in development. There's no paid plan yet, so early adopters can try it completely free. For people who live with 20 tabs open at all times, it might finally be the first browser that feels like a genuine AI partner rather than just another app. From browsers to filmmaking, the next breakthrough comes from Holocene, developed by HKUST and Ant Group. It's an open-source video model designed for long-form storytelling capable of generating multi-shot sequences with consistent characters, lighting, and environments. What makes it stand out is that it understands real cinematic grammar. Things like over-the-shoulder cuts, camera zooms, and smooth dolly movements that make a sequence feel professionally directed. Holocene remembers visual details across shots, so a character's outfit, prop, or facial scar stays perfectly consistent throughout the video. It comes in several versions: a 14 billion parameter full model for best quality, a faster sparse edition for speed, and smaller 5B builds for limited hardware. Under the hood, it uses WAN 2.2's VAE and a T5 text encoder, and it's optimized for Flash Attention 3, though it can fall back to FA2 if needed. The workflow gives creators an unusual amount of control. You start with a global scene prompt describing the setting, characters, and tone, then add short per-shot captions to define each camera angle or dialogue moment. That structure lets the AI do most of the heavy lifting while you focus on direction. The full attention mode delivers the most cinematic results, while the sparse version runs faster with minor stability trade-offs. The team openly compares its quality to closed commercial systems like Sora 2 and Kling, claiming similar coherence over longer scenes. Since it's completely open source with all inference code available, filmmakers can plug it straight into their pipelines without waiting for private beta access or proprietary tools. And finally, Google is extending AI to the real world in a way that might actually save lives. The company's Earth AI platform, which already powers early warning systems for floods, wildfires, and air quality threats, just received a major update built around Gemini. Earth AI currently provides forecasting coverage for more than 2 billion people and helped alert around 15 million residents during the 2025 California wildfires. Now, Google is adding what it calls geospatial reasoning, a system that links weather models, population data, and satellite imagery together. Instead of just asking, where will the storm hit, analysts can ask which communities, roads, and hospitals are at risk and get a single integrated answer within seconds. These capabilities are also being added into Google Earth itself. With natural language queries, analysts can highlight patterns like shrinking rivers, dust storm regions, or early signs of algae blooms that threaten water supplies. The new tools are rolling out in the United States for Earth professional users. with expanded access for Google AI Pro and Ultra subscribers. On the business side, Google is opening Earth AI's core models, imagery, population, and environment through Google Cloud so organizations can merge their own data and build predictive systems of their own. The World Health Organization is already using it to forecast cholera outbreaks in the Democratic Republic of the Congo by analyzing rainfall and sanitation data. Planet and Airbus are integrating it to monitor deforestation and detect vegetation around power lines to prevent outages, while Alphabet's X division is collaborating with insurers to improve hurricane damage prediction and speed up recovery efforts. In short, Google is transforming decades of mapping and satellite research into a real-time decision engine. With Gemini's reasoning now inside the loop, Earth AI isn't just showing the planet, it's actively understanding it. So within 1 week, AI managed to compose music, manage browsers, direct films, and map the world itself. These systems are no longer isolated experiments. They're merging into an ecosystem where creativity, analysis, and reasoning all overlap. Will AI soon handle our soundtracks, edit our movies, and forecast the next natural disaster before it even forms? That future doesn't sound far away. Google just released something that could redefine how apps are built. It's called vibe coding, and it just landed inside AI Studio. The idea is simple but powerful. You describe the app you want, and Gemini builds it right before your eyes. No API setups, no tangled configuration, no debugging chaos, just instant creation. In Google's demo, one short prompt built a VEO-powered video maker, another generated an image editor using Nano Banana, and a third produced a writing tool tied directly to Google search. Everything happened live as Gemini connected the logic behind the scenes. It's fast, fluid, and feels like coding finally turned conversational. The new AI Studio interface matches that energy. The app gallery isn't a dull list of templates anymore, it's a visual showcase filled with working examples you can preview, remix, and rebuild. Each project includes starter code that actually teaches through action instead of long documentation. If you're stuck, an I'm feeling lucky button jumps you straight into a ready project, so you never waste time on a blank screen. And while your app compiles, Gemini runs quietly in the background with something called a brainstorming loading screen, feeding you layout tweaks, animation cues, and small feature ideas you might not have considered. Those seconds waiting suddenly become creative ones. The real magic starts once your first version is up and running. Annotation mode fixes one of the most painful parts of app creation, the endless search through code just to change how something looks. Here, you highlight what you want to adjust and talk to Gemini directly. Say, make this button blue, slide this image from left to right, or tighten the padding around these cards, and it applies the change instantly. The difference in momentum is huge. You stay in flow, stacking small wins one after another without losing focus. For anyone who builds regularly, that shift from tinkering to sculpting makes the process lighter and far more fun. Another clever addition tackles the problem of limits. When you hit your free quota, you can plug in your own API keys and continue working seamlessly. Once the usage resets, the studio flips you back to the free tier automatically. It's a small feature that quietly removes one of the most common roadblocks in side projects. Combined with the new end-to-end flow idea, build, annotate, and refine, the message is clear. Google wants app creation to feel less like engineering and more like collaborating with a smart teammate. There's also a parallel update inside Gemini's Canvas that follows the same work where you think idea, slides. It's not a pack of templates, but an AI presentation builder that generates decks from prompts or uploaded material. Drop in a document, spreadsheet, or research paper, and Gemini creates a presentation grounded in that content, complete with design, images, and structure. You can export directly to Google Slides, edit as usual, or share with your team. It's available across personal and workspace accounts, so students and professionals get the same treatment. Canvas first launched as a creative space for writing and coding, but this turns it into a presentation studio for anyone who teaches, pitches, or reports. These two releases complement each other perfectly. Vibe coding speeds up building, Canvas Slides speeds up presenting. Both erase friction at points where people usually stall. You start faster because setup is instant, and you finish faster because edits happen in the same place where ideas form. For users already inside Gemini, the shared design language, talk, watch it, act, adjust live, creates one connected ecosystem. Looking closer at vibe coding, its most important change is invisible. Multimodal apps used to mean juggling endless parts. Connecting APIs, handling rate limits, caching data, managing rollbacks. AI Studio now decides most of that for you. You focus on creativity, while Gemini handles the structure underneath. Annotation mode then closes the loop. You describe the change, Gemini edits the code, and you see results immediately. It's a better contract between human intent and machine execution. There's a clear accessibility goal too. Many people have good ideas, but give up before reaching a prototype because the workflow demands jumping between designer, integrator, and tester roles. Vibe coding merges all that into one continuous process. Start with a sentence, get a draft, refine it live, and ship. Beginners can finally create something useful, and experienced developers skip repetitive steps. Anyone who's spent hours wiring authentication just to try a new idea instantly understands the value. Even resource handling feels smarter. Instead of stopping when you reach a limit, adding your own keys keeps you working. And once limits reset, you slide back to free mode. Pair that with the remixable app gallery full of working projects already tied to Gemini, and you have a built-in learning hub instead of random code snippets from the internet. Canvas Slides completes the creative loop. After you finish building, you often need to explain your work to a client, teacher, or audience. Now, you can upload your notes, choose a topic, and Gemini turns them into a clean deck with visuals and key points. Export to Google Slides, tweak what matters, share the link. Done. It's the same philosophy again, less setup, more results. Together, vibe coding and Canvas Slides create a natural rhythm. Build fast, present fast, move on to the next idea. It's clear Gemini is evolving into a full creative partner rather than just an assistant. All this innovation arrived alongside a serious security alert that deserves attention. Reports surfaced about a massive Gmail-related credential leak, around 183 million Google account logins circulating on underground forums. It's not a breach of Google systems, but a massive combo list built from old third-party leaks, phishing kits, and stolen databases merged into one file. Security analysts say it includes email addresses, hash passwords, and in some cases plain text ones, plus login metadata that helps attackers automate testing. Roughly 40% of those credentials still work, which is a massive number of exposed accounts. The attacks are automated, not manual. AI-driven credential stuffing tools cross-match old leaks with current data to find live accounts. Once one works, intruders set up filters, forward emails, spoof alerts, and attempt to access other services where the same password is reused. Even users whose emails aren't listed may receive fake security messages that appear authentic because compromised accounts are being used to target contacts directly. Google's response is clear. Its infrastructure is secure, but user behavior is the weak link. The company is forcing resets on risky accounts, encouraging two-factor verification, and promoting passkeys. If your address appears in a breach database, change your password immediately. Use a unique, long passphrase, enable an authenticator app, and run Google Security Checkup to remove unfamiliar devices or apps. Never click account confirmation links in random emails. Always go through your account settings. Investigators have already traced millions of phishing attempts tied to this data dump across multiple regions, and the cleanup will take time. In short, while Google is transforming how people create with AI, it's also reminding users to protect what they create. The message underneath all of this is simple. The future of building, sharing, and securing information is becoming conversational, and vibe coding is the clearest proof of that shift so far. There's a new model shaking up the open source AI world, and it might be the strongest one yet. It's called Minimax M2, created by the Chinese startup Minimax. People are calling it the new king of open source AI models, not because it's the biggest, but because of how smart and efficient it is, especially in agentic tool use. That means it can plan, act, and use other tools on its own, like browsing the web, running code, or operating apps, with very little human input. It's the kind of skill future humanoid robots will rely on. The biggest deal here is that Minimax M2 is completely open source under the MIT license. Anyone can download it, retrain it, modify it, or use it for commercial purposes with no restrictions. It's available on Hugging Face, GitHub, and ModelScope, and even supports OpenAI and Anthropic API formats. So if a company already uses GPT or Claude, they can switch easily. According to Artificial Analysis, the group that benchmarks AI systems, Minimax M2 now ranks #1 among all open models worldwide for reasoning, coding, and task execution. On Tau Squared Bench, it scored 77.2, on Browse Comp 44.0, and on Fin Search Comp Global 65.5. These scores put it right next to GPT-5 and Claude Sonnet 4.5, models that cost millions to train and are closed source. The secret is in its mixture of experts design. It has 230 billion parameters, but only 10 billion are active during inference. That makes it powerful, but efficient. It can deliver frontier-level performance while running on just 4 NVIDIA H100 GPUs, which is realistic even for mid-sized companies. Artificial Analysis noted that Minimax M2 isn't just strong on paper, it's consistent across real-world tasks like coding, automation, and multi-step reasoning. It's built for workflows where the AI plans, executes, and verifies complex steps, which is perfect for enterprise automation and developer tools. LLM engineer Pierre-Carl Longley summed it up best when he said, Minimax is mastering the tech end-to-end to get actual agentic automation. And he's right. Minimax isn't trying to build the biggest model, it's trying to build the smartest usable one. Performance-wise, the results are impressive. On a Sweetbench Verified, it scored 69.4, GPT-5 got 74.9, on Artifacts Bench, 66.8, higher than Claude 4.5 and DeepSeek VEO 3.2. On Gaia, text only, it hit 75.7, and across agentic tasks like Browse Comp, it easily outperformed every open model available. In Artificial Analysis's Intelligence Index version 3.0, it earned 61 points, making it the top open-weight model globally, just behind GPT-5 and Grok 4. The report highlighted its balanced intelligence, not just raw reasoning, but applied intelligence across real tasks. Minimax designed the M2 for developers from the ground up. It can handle multi-file code edits, automated testing and debugging, keeping its reasoning visible through think tags. Those tags show its step-by-step logic, which helps developers understand how the AI thinks instead of guessing what happens behind the scenes. It's also great at agentic planning, meaning it can combine tools like browsers, terminals, and APIs in one flow while maintaining logical consistency. That makes it perfect for building AI agents, coding assistants, and even humanoid control systems that need to reason and act continuously. Minimax even published a tool calling guide on Hugging Face showing how to connect external apps through XML-style tool calls. You can literally use it as the reasoning brain for larger systems. And it's cheap, shockingly cheap. The API costs 30 cents per million input tokens and $1.20 per million output tokens. GPT-5 costs $1.25 and $10 for the same thing. Claude Sonnet 4.5 costs $3 per million input tokens and $15 per million output tokens. Minimax offers similar performance for under 10% of the price. Artificial Analysis lists its average blended cost at 53 cents per million tokens, making it one of the most cost-efficient AIs out there. The latency to the first token is just 1.16 seconds, and it generates around 82 tokens per second. It's not the fastest model, but its accuracy and reasoning more than make up for it. The context window is 200,000 tokens, plenty for large projects or detailed prompts. You can use it via Minimax Agent, a chat interface, or the Minimax API, both free for now. If you want to host it yourself, you can download the model weights from Hugging Face and run it using VLLM or SGLang. Both support its special reasoning structure. Minimax recommends temperature 1.0, top P 0.95, top K 40, and warns not to remove the think sections when passing chat history. That's where the logic continuity lives. Minimax story is just as impressive as the model itself. The company first got attention in 2024 for its AI video generator, VEO 3.1, which could produce lifelike cinematic clips in seconds. One of those clips, a Star Wars-style duel, went viral online and made Minimax a serious player in generative tech. Then in 2025, they launched the Minimax 3.1 series with context windows up to 4 million tokens, which was double Google's Gemini 1.5 Pro and far beyond GPT 4.0. Later, they released Minimax M1, which focused on reasoning and efficiency. That model introduced a reinforcement learning method called CISPO, and according to reports, it was trained for just $534,700, about 1/10 of what DeepSeek spent on its R1 model. Now, Minimax M2 is the result of all that progress, more stable, smarter, and optimized for real-world use. Backed by Alibaba and Tencent, Minimax has quickly gone from a startup to one of China's biggest AI powerhouses. In benchmarking data, M2 stands shoulder to shoulder with GPT-5 and Claude Sana 4.5 across tasks like AIME25, MMLU Pro, GPQA Diamond, Live Code Bench, and IF Bench. It's often just a few points behind, despite being open source and far cheaper to operate. That's exactly what enterprises want today. Transparent, customizable, affordable AI. Not just the smartest system, but one they can host themselves without compliance headaches or massive licensing fees. Minimax M2 checks every box. To see how it performs in the real world, a YouTuber named Bijan Bowen tested it in depth, and the results were surprisingly good. After a few connection issues, the model ran smoothly through the API and OpenRouter. He described it as fast, logical, and creative. When he asked it to simulate an operating system, it actually produced a working desktop-style interface. When he asked for websites, it built working HTML pages with nice layouts, color gradients, and hover effects. It even refused shady prompts like a fake Bitcoin duplicator, showing it has balanced safeguards. Then came the fun part, coding tests. The model generated a 3D racing game with car physics, camera angles, and even suspension movement when turning. He said it was the best result he's ever gotten in that test, better than anything from other open models. He also tested creative tasks. He asked for a PC repair website featuring an owner who refuses to fix Macs. The model delivered a full site with text, design, and even a funny backstory explaining why. Buttons worked, contact forms were included, it was all there. For his final test, he asked for a drag-and-drop PC Builder simulator. The result wasn't perfect, it didn't fully render, but it showed strong logic and structure for such a complex project. In the end, he called Minimax M2 the best open source model he's tested so far, especially for coding and creative agent tasks. For those following humanoid robotics, this kind of advancement matters. Models like M2 can run reasoning cycles like cplan, act, verify in real time, which is exactly what humanoids need to operate independently. And because it only activates 10 billion parameters at once, those cycles can happen fast without massive hardware. A real step toward giving humanoid robots an open, affordable reasoning engine that's actually transparent and efficient. Minimax M2 shows that open source AI isn't just catching up, it's ready to compete with the world's best. But Microsoft's new reinforcement learning framework for AI agent, Microsoft. They've just released something called Agent Lightning, and it's a big deal for anyone working with AI agents. The whole idea behind it is simple, teaching AI systems to learn from their own experiences without having to rebuild the entire system from scratch. Think of it like giving an AI memory of what worked and what didn't, then letting it improve from there. Agent Lightning takes what they call real agent traces, basically logs of what an AI does, and turns them into reinforcement learning transitions that can be used to retrain the model. What's cool is that it works with existing agent stacks like LangChain, AutoGen, or even OpenAI Agents SDK, and you barely have to change a line of code. At its core, Lightning RL figures out which actions were good or bad and fine-tunes the AI using methods like PPO or GRPO. Training happens on a Lightning server, which handles updates and serves the improved model through an OpenAI-style API, while the Lightning client runs where your AI already lives, like your browser or development environment, sending activity logs back for training. It also uses OpenTelemetry so developers can track everything easily. Microsoft tested Agent Lightning on several tasks, SQL generation with Llama 3.23 billion, retrieval-based answering using MooSequa and a 21 million document Wikipedia index, and math problem solving with AutoGen on CalcX. In every case, results kept improving. A key feature called Automatic Intermediate Rewarding, AIR, gives the AI small rewards during long tasks, helping it learn faster and more effectively. In short, Agent Lightning makes AI agents smarter by learning directly from real-world use. So while Microsoft focused on teaching AI to train itself, Adobe focused on teaching it to make music. The Firefly suite just got two major AI audio tools, Generate Soundtrack and Generate Speech, letting you create custom background music and realistic voiceovers directly inside Firefly. The best part is that everything made with it comes with a universal license, so you can use the music freely in YouTube videos, ads, or commercial projects without worrying about copyright issues. Adobe trained its models only on licensed audio, so there's no risk of takedowns. When you upload a video, Firefly analyzes it and automatically creates a short music prompt describing the mood, genre, and purpose. You can adjust things like tempo or energy, then hit generate. In about 2 minutes, it produces 4 instrumental tracks that fit your video length, up to 5 minutes. You can download or tweak them as needed. Generate Speech works just as smoothly. You can upload a script up to 7,500 characters, choose from 50 voices across 20 languages, and fine-tune tone, pauses, or pronunciation with a built-in fixed pronunciation option. Adobe also partnered with 11 Labs and Topaz Labs, so both the voice quality and enhancement options are top tier. Alongside that, Firefly now includes its 5th generation image model in beta and a new multi-track video editor, making Firefly feel more like a complete creative studio powered by AI. Speaking of energy efficiency, researchers at the University of Surrey just revealed something pretty wild, a brain-inspired AI architecture that's both faster and way more efficient. The system, called topographical sparse mapping, changes how neural networks connect. Instead of linking every neuron in one layer to all neurons in the next, which wastes tons of energy, it only connects to nearby related neurons, mimicking how the human brain processes visual info. The upgraded version, called Enhanced Topographical Sparse Mapping, adds training time pruning that, like the brain, keeps useful connections and drops the rest. In tests, it reached up to 99% sparsity while matching or beating accuracy, used under 1% of the energy, trained faster, needed less memory, and points toward brain-like neuromorphic hardware. Now moving from brains to bots, 1X Robotics has opened US pre-orders for its first humanoid housekeeper, the 1X Neo, a robot built to handle everyday chores like laundry, cleaning, and serving coffee. It can walk, climb stairs, recognize people and objects, and even recharge itself by plugging into its wall dock. Standing 5.5 feet tall and weighing 66 pounds, it runs for about 4 hours per charge. Powered by a tendon drive system, Neo moves with human-like precision, able to handle delicate items like glassware. It has 4 mics, 3 speakers, and 2 8-megapixel cameras, and its hands have 22 degrees of freedom. It can lift 154 pounds, carry 55, and stays quiet at just 22 decibels. The soft, 3-dimensional lattice body is wrapped in washable fabric. For now, complex chores still rely on a remote expert mode operator until Neo learns them, though users can blur faces and set privacy zones. It costs $20,000 or $499 per month with a $200 deposit, available in tan, gray, or dark brown, and international shipping planned for 2027. While 1X is bringing humanoids into homes, Pinterest just launched its own AI assistant, though this one's all about helping you shop and decorate. It's a visual-first tool that pulls recommendations from the platform's massive network of over 600 million monthly users. You can talk to it directly, saying things like, "I need new throw pillows that match my living room decor," and it'll search through similar boards, saves, and collages to give personalized results. It's like having a stylist who actually knows your taste because it's learned from everything you've pinned over time. Meanwhile, IBM just released Granite 4.0, a new family of compact AI models built for businesses. They come in micro, tiny, and small versions and use a hybrid design that mixes Mamba 2 and Transformer technology. Regular Transformers slow down as context grows. Doubling context makes them 4 times heavier, but Mamba scales linearly, staying fast even with long inputs. Granite uses 9 Mamba blocks for every Transformer block, combining speed and detailed reasoning. The efficiency is impressive. The micro model runs on just 10 gigabytes of GPU memory, while others may need 60 gigabytes. The tiny model has 7 billion total parameters, but activates only 1 billion at a time, thanks to a mixture of expert system that turns on only the parts needed for each task. IBM also removed positional encoding entirely, a feature they call NOPE, eliminating limits on sequence length. According to IBM's Martin Keene, the small model beats nearly all open models in instruction following and rivals even top-tier AI systems in complex function handling. On the developer side, Google AI Studio just added new logging and dataset tools that make debugging much simpler. With one click on Enable Logging, it automatically tracks every Generate Content API call successful or failed without writing any code. You can filter by status, inspect inputs and outputs, and trace where issues appear. The logs can be exported as CSV or JSON-L datasets for testing or shared with Google anonymously to improve models. It's free in all regions where the Gemini API runs and gives developers a clear look at how their AI apps perform in real use. And finally, Figma launched Figma Weave, a rebrand of the Weavy platform. It's a node-based AI workspace where creators can link multiple AI tools and models on one canvas. You can connect an image generator, a video editor, and a captioning model into one seamless workflow instead of switching between apps. Each node represents a tool you can tweak or compare results from side by side. Figma calls it a new way to shape AI outputs, not just by prompting, but by creatively controlling and combining them. That's all for now. Thanks for watching, and I'll catch you in the next one.